Hello, and welcome to the AmiWest 2023 Devcon Day 1 live stream. This edited version of the live stream is going to contain a presentation by Solie on Spotless debugging, Harald Kanning on the NVMe driver for Amiga OS 4, Solie again talking about DMA engines for the Amiga 1 X5000 and A1222 Plus, as well as Dan Salvato with his Magicore Anomala game development environment. Please enjoy.
Audio. Oops. Okay. I'm talking now. It's okay.
Echo though, doesn't it? I can always turn the fan on easily.
It sounds pretty good. AmiWest 2023 Devcon Spotless 2 source level debugger.
You have an USB.
Another one? Oh man. Yes, I do.
All right, this is a little bit nicer, Mike.
Sure.
And where are we at?
I'm good. Wrong side. That's my keyboard. Actually, I could put it on this side and move my keyboard to that side because that's fat.
Okay.
Right. It might not work.
Oh, it's on the wrong side.
Right. No. It's RNO PDF. It's basically he's using all of this thing. Okay. Yeah. I can use that. Yeah. Okay. So fine. The coordination I was talking about? Yeah, extension. I can just extend of it. There it is. So if I go ahead and I use yeah, that guy. Yeah. All right, so ready, steady for the next page. Whereas with Hollywood router.
I like this.
Yeah, I mean, like it's way faster.
I don't know where.
At least it is on table.
Human speed.
Yeah, it's just way better on table.
Well, yeah, I do all these PDF manipulations, and they take 30 seconds. So I feel like that's I'm interested. Well, you know, with PDF pages and things like that.
Yeah.
I gotta start over.
Great.
Yep. Yeah, right. I don't know why that's USB. It's time for that. Yes, yes. No keyboard. Nonsense. I paid for it, it can work for me. If it doesn't like it.
So.
There you go. RNO PDF.
You know, my first
Okay, back line.
Or no PDF, it didn't work.
No, it didn't work very well either. Yeah.
A lot. So now he's fixed.
Well, actually, I think Andreas has fixed it.
That's what I mean. Yeah.
I mean,
You have Hollywood.
Okay, got my video back.
old version.
Because that was the biggest thing I found with most Hollywood apps is. If you had a Hollywood and you was installed with the Hollywood apps work great. If you don't, you're really to buy a slew of, oh, this is missing, that's missing, this is missing. And you can never get things to work. I mean, some things do, but.
I mean, this is Hollywood Designer 5. Steve, it looks great.
No.
I understand.
If you have Hollywood installed, Hollywood apps, if you don't have Hollywood installed, then it was.
I'm easy. Steve, I'm hearing you again a second time.
I don't know what I got kicked out of the
Or
meeting.
is that Trevor? I can't tell.
Oh, whatever happened about 30, 45 seconds ago.
No, the Zoom will kick you out. The idea is that to let it be up, the bandwidth be off.
Actually, you know what? That's a good tip for a guy. Use RNO PDF. I won't do that.
Well, that, and then Amy PDF, that's a
Are you guys
bad
gonna
coding.
do the 1222 presentation? I think you're now. 1222 presentation?
Yeah, I
I have a sample of 40.
I'm going to- I'm going to.
Very good.
Oh, hit 2 keys. 1 0 1 0.
Steven and Trevor.
Well, let's make sure that the mic is selected.
No,
Yeah.
but I didn't bring it for now.
It should be like a USB advanced. Yeah. Yep. Okay. Pick it back.
That looks good to you?
Yep. So now you are on this mic.
Okay.
So is
Okay.
everybody else.
All right.
Hello, my children.
So when you're speaking, I'm gonna have these speakers off, so we don't get a feedback and make it hard to speak, so.
Yeah.
So you're gonna be unmiked for this room, but mic'd for Zoom.
Okay. Trying to mute, so I hit mute on this thing. And you still hear me on mute.
Let's see, let's see. All right, spot.
So this is working, this mute works.
Yeah.
Yeah, this is good. Okay,
Yeah.
turn yours off now.
Well, go
Turn
ahead.
on. Okay, okay, okay. We're good, we're good.
We're good. We're good.
That's right, Tom. Steve is talking.
Yeah.
I can hear Bill's sexy voice, but I don't know how.
Like, then get your order in.
Oh, okay, little speakers there.
Microphone, I'm not muted.
Okay, I think we're finally got everything going, you think? That long?
Well, it's going. Bill through Zoom, through YouTube. Streaming to me here.
If you say so. Okay, I don't need this window. I need this window. And I need this. And am I happy? I think I'm happy. What's this little thing here? I don't want that. Can you get rid of this? Whatever the heck that is. Oh. How do you make this go away? I guess I don't. Okay. Are we ready to start?
You need, you. What do you want to make?
I can't get rid of this.
MS.
Oh, you don't see it on your screen? Or I see a weird thing on here, this little thingy.
That thing? All right.
No? Oh, okay. I don't know. I guess maybe you can't see it and I see it. This little talking Stephen Solie thing.
Oh, that must be the
Zoom.
Zoom.
Yeah. No one else sees it?
Yes.
That's your webcam with you, right?
I don't know. I can't tell what's what. This is just Zoom. All I know is Zoom. And I put on full screen and I got the little talking thing. I don't know what that is.
I think that's like the little.
What is this? I don't know.
Oh, so you're presenting?
Yeah.
So the Zoom feed minimizes automatically and turns into that.
So no one sees it. That's
can be
all I
on
want to
it.
know.
Yeah, so no one sees that.
Okay.
That's your view of Zoom.
Yeah,
Okay.
that little window, right. Can't you
So-
drag that around?
I don't know. I don't want to touch it. It's, I'll probably screw it up.
All right, back to
You
your
said
page.
you're-
Oh, there it goes. There it goes. Oh, it didn't have a bar. Anyway,
The most, innocuous.
there you go. There you go. Good enough.
Yeah, I won't.
Thank
my
you, sir.
wife's technological capabilities of this group.
So is this what everyone else sees or?
We're the computer club that doesn't use computers, you know
I
that.
won't share my wife says about the technological capabilities of this group.
So is Robert good?
Ending in 1995.
Are you good, Robert? You can hear, you got audio, you got video? Okay, so we got Robert satisfied. Good. Now is Bill satisfied? Is Bill Basari satisfied?
Is Bill Basari ever satisfied?
There's always, always has an update.
Did you hear that? Did I waste the slag?
Jerry, do you know if Bill's satisfied?
I think they're good enough.
Yeah? Can I start then?
Yes.
I'm able to?
So.
I would like to say hi for a second if you.
Where am I? What the heck? Hold on here. What? Oh, there we go. There we go. Yes. You want to say hi on the mic?
A little bit.
How do you know? when the
Robert,
lights on or off? Are you
uh,
on already?
he wants to do a blurb.
Yeah, just say hi.
Wants to do a
You want
blurb.
to open
Okay.
the meeting.
Yeah. Yeah, just.
Can I sit or?
Yeah, whatever you want to do. Yeah,
That's Steve.
Okay.
You guys are all alive.
good, cool. Well, it's great to see everybody here for the DevCon. This year, I know absolutely nothing about it, which is a great feeling. Everybody else has done all the work. And it's fantastic to have Jerry and Stephen and Robert and a whole bunch of other people who have been involved in the planning for this. It's great to see everybody here pushing Amiga forward like we do here at this show. And the show, as always, is all about the people. So if we didn't have anybody here, we wouldn't have any show. Thanks for coming. It's really great to see you, and I have to work today, so I won't be around for the rest of the day, but I'll probably see you tomorrow and for certain for the weekend. So thanks for coming, and I'll turn it over to the people who actually know what they're doing.
Okay, so where are these people that know what they're doing?
Right there.
When are they getting here? We'll let you know when they arrive.
Oh, it's a little complicated this year. We got all sorts of interesting things going on. Anyway, hopefully people on the internet are satisfied, and the people in here are good. You can hear me okay, everybody in the room? Okay, Robert's good. Yeah, that's the important guy.
Yeah.
Keep the cameraman happy. Okay. So we're starting a little bit late, but not too bad. Half an hour, right? So I wanted to do a blurb on Spotless 2, it's called. And you might not have seen this because it's got some interesting requirements. But I've managed to put those requirements on my computer here, and so I can show it off. So Spotless 2 is a source level debugger. So you get a nice visual code type debugger that you can see, and you can pick out the line numbers and all that good stuff. It's by a fellow called Elfkill. At least that's how I pronounce his name. I hope I didn't destroy it. Wintermark, and he put it up on OS4 Depot, and he's looking for donations. So when/if you get this program and you actually find it useful, please donate, because he put a lot of work into this. It's a very good debugger, and he went above and beyond just the debugger, because the operating system had problems and bugs in it and features missing, and he added those features just to make his debugger work. So he went way beyond just a debugger. Okay. And he did not charge too much money. Zero. So I just wanted to point that out. Let's see if I got the right keyboard. There we go. I got multiple keyboards, multiple mice. So this is this previous incarnation of this is DB 101. You might have used that if you're a programmer type. It was called DB 101. DB 101 is up on GitHub and 80 tools, I believe. And so is Spotless 2. The source code to the debugger is actually up on GitHub too. So if you don't like it, go fix it. It's got standard GUI, standard Amiga GUI. It's got all the usual stuff you expect a debugger to have, which I'll show you in a minute. Variables, stack trace, disassembler, registers, all that good stuff. I'll get the right manual or the right keyboard eventually. So this is the sticky point. You need kernel 5457 or greater and ELF library 5342 or greater. You can't have them because they're not released yet. So one of my tasks is to talk to the boss, who isn't in the room right now. He's probably recovering. Last night got a little crazy. We need to get these out to the general public because everyone else outside of this room doesn't have it. Now, the people in this room can have it because I have the files right here. So I plan to share them for anyone who wants to run it. Okay. it's perfectly legal as long as I get the boss's nod, which he isn't in the room, but I'm sure
He also saying no.
he did not say no. So there you go. So you guys, you can all have a copy. And I trust you because you got happy faces. Except for the one guy in the shades, he looks suspicious, but the rest of you are good. Okay. Now, we are going to delve into some assembly language because this source level debugger will show you the source code and the assembly beside it. And I have not seen this on Amiga for a very long time. And I'm glad to see it back. Very glad. Now, I am not good at PowerPC assembly. I am not good at it. Okay, so I'm going to try, but don't expect miracles from me.
We got a comment in from the people online saying they can see the Amiga OS screen that we see and not the slideshow.
They can't see the slideshow.
They cannot see the slideshow. Were you expecting to be showing the slideshow right now?
Mhm.
You can't see the slideshow either.
I'm showing it on Zoom.
See that?
There's no slideshow? There's a slideshow?
Yeah,
Oh, who knew?
Showing a
We thought you were just
slideshow
talking.
itself.
I'm sorry. I could easily fix it.
We thought you were just talking.
Yes.
How do I? Where's Zoom? I wasn't sharing my screen. That's my fault. It's okay. I'll fix it.
Always your fault.
Wait, what the heck? Get him out. Oh, no, cancel. Where's the Zoom? I love Zoom, by the way. It's great. Love it. It's fantastic. Where's share screen?
Go to the bottom, the buttons. Dock. Oh, the bottom. There you go. See the
Why do I? What the?
green at the bottom.
I don't know what you're talking about.
Are you seeing what's on the screen there?
No, I don't know what that is. Where is the settings? Sorry, I can't find them. All I see is this. What is this?
Oh, you're not even on the stream, are you?
It says I am.
Okay.
Stop video.
Wait, click in there. Oh, okay, what about that? Ah, there you go.
What
Click
is that?
down there.
Oh, there it is. Sorry. Thank you, expert.
Wait. Now you want to make sure. There you go. That's
This
the
one. That's the one I want to share, or do I want to share this?
No, that's the one we've been seeing.
No,
I think.
want-
No,
no.
maybe not. Okay. Yeah, do the one. That's the one we've been seeing, but you want to show that?
Oh, okay. Why does it look funny?
Whatever.
That's weird. Okay, there we go. Sorry, I will.
Slide,
Uh,
it'll refresh in a
I
second.
got a bunch of stuff blocking me here. Where?
Another happy Windows user.
Where is? Oh, there it is. Found it. Okay, there we go.
It's all very easy without this. So.
There, now it's better. Okay. So yeah, like I said, there's the donation, blah, blah, blah. Yeah, there's the versions you need,
Okay,
by the way.
that's what we want.
right? That's all you get. Okay, sorry. Teasing. So you need 5457 kernel, right? ELF library 5342. You good?
Yep.
Okay. People in the room always get preference. So references, like I was just blurbing about how crappy I am in PowerPC assembly, blah, blah, blah. And one of the reference manuals is called EREF. You need that. Even though Freescale doesn't own it anymore, NXP does, but they still call it that. You can find it on the internet, or I brought a copy for everybody in the room. So
Memorizing in one go.
yeah, memorize it. Now we're going to get into Badgie. Anyone know Badgie? No?
Lower decks.
There's one guy. There's one. There's two. So I brought Badgie. Anyone who knows Badgie knows he's pretty naughty. Okay, so we're gonna look at Badgie and hopefully we survive. Okay. That's what I called my test program. I thought it would be appropriate. Yeah,
It's murderous creature.
you're not supposed to say that out loud.
You have to say it 3 times.
Okay, now I'm gonna try to bring up my my camera here. One moment. Doc screen sharing is paused. New share. Camera. Share. Close other apps. Okay, what are you complaining about? What other apps?
Looks like another app is using the camera already.
What other app?
What camera are you trying to share?
My camera. Where is it? Hold on. I had it working before my crash. What? What do you mean another app?
Well, Zoom is using it, obviously.
Yeah, but I want Zoom. I want Zoom to stop share. Okay. Get the camera working again. Is this PC on?
Yeah.
Are we sure?
Yep.
Yeah. I don't see it. That's why I'm confused.
Well, it's there and working, just.
Those other apps again. What do you want me to do? Computer? Chat? Record? I'm going to stop the video for a second and get this working. There we go.
Yes.
That's what I want. Yes. Okay. I want that. And I want to share that. Okay.
All we see is your name. Now
Now you see something, I hope.
One workman.
There we go. There we go. Okay. Okay. We got it. Don't worry. Don't panic. I'll tell you when to panic.
No panic.
No, not yet. It's coming. Which? That's the PC. That's the Amiga. Okay. Got the Amiga. So hopefully I can make this visible. Give me a minute. And this one. Font Topaz like 30. What? How does it work again?
Yeah.
Name size. Isn't it called Topaz? What? No. Remember how to make the text large in the shell?
Yeah, there's a preferences editor.
I thought there was set font. Oh, there's a preferences editor now. Okay. What's it called? Console?
No, I was just right click.
Right click.
On the
Okay.
menu.
Settings, edit.
Oh, wrong menu. Get this out of the way. Sorry. That's how we did it last year.
Here's, oh, fantastic. Mine.
Oh, I used the wrong font probably, whatever. How do I make it big? Where's the big button?
Like that, pick a font.
There's no.
And then you get the size.
Yeah.
You should. Oh, there, I had to click. Jeez, okay. Okay, which one is it normally? Topaz?
No.
Mono?
Do you have wingdings?
Listen, I'll send Badgie.
Bitstream, Vera, Bitstream, Vera, Sans, Mono. It's the default Amiga OS font
Is it?
for the shell.
Okay, you say so.
Use.
It's just, it's laggy. It's laggy. Oh, wrong menu. There we go. Ah, whew, sorry. I am, oh,
There's this thing, Steve, it's called Amiga OS.
Yeah.
what is
You
it?
should try it sometime.
You might be interested in it.
I know.
I'm
I've
getting,
never seen it.
Badgie's coming. Telling you.
Right here.
Okay, so I got Badgie here. And a bunch of other junk. There's the reference manual. So what I'm going to do, I think, is first compile it. So you might think, oh, that's hard. No, it isn't. Don't worry about it. Oop, oop.
Veggie.
There you go. I just compiled it. So the secret to debugging, though, is you have to put G stabs on there. See that option? -G stabs. Stabs are good. Badgie likes stabbing. Okay. Another, he likes to stabby. Okay. And so you have to put -G. That's for what do we call it? G debug? I think that means debug
What?
in GCC land. -G. I don't remember.
I don't know all the arguments.
You don't know them off the top of your head?
That's why somebody creates a nice make file for me. I don't have to know.
People call yourselves programmers.
Maybe that's what we got code bench for.
Can I put -G? No, it's not gonna work.
Call the compiler directly since college.
What?
It's true.
What?
Everybody makes nice make files for me. I don't have to bother.
What kind of freaking developer are you?
Oh, I'm not a software.
What does -G mean? I'm just gonna look it
You're not a
up.
software guy, but freak, come on.
Well, it's always easier to let somebody else do it.
Yeah.
-G. Anyway, it's in there somewhere. There, options starting with -G. Anyway, you need -G. Don't worry. I gotta find it right now. And you have to put stabs because stabs is the debugger object file additions. Like it puts in all the wonderful line numbers of the source code and what goes with what. Like it's like the index, a cross-reference, so that the debugger can take the stabs information and your source code file, mix them together and show you a lovely GUI, right? And that goes for any computer. Just they usually hide it for the weak who can't remember the command line. Okay. Now we'll start up Spotless. Now Spotless is a GUI, like I said. So I've compiled my program with stabs. It's ready to go. Now I popped up the GUI for Spotless, right? I don't think I can make that font very different, maybe, but you could kind of make it out. Yeah, sort of. Is it okay on the video?
Yeah.
Can you make it out? It's okay.
A little tight.
Little tight. So I'm going to load the program. So you got to load your program that you're going to run. That's always the name of the game. So I'm going to go find it. I didn't put it in the, there's Badgie. Okay, I'll load them up. Now, the first thing it's going to ask is, okay, do you have any command line arguments for Badgie? And I don't. So that's just no. That's your arguments like -G this, whatever you like. Okay, and now it says, okay, I can't find the source file. Which one is it? Well, it's this one right here. Ta-da! There's Badgie. That's this program. Now it's going to be tiny, probably. I don't know if I can make the font larger on this sucker. If there's a way to do it, I don't really know what it is. Configure? No, that's not it.
You're the devs of this stuff.
But fortunately, the source code for this is public, so we can fix it here. You guys have a few hours. Okay. So it's got all sorts of wonderful windows and things. The important part, at least in my mind, is these little boxes on the left-hand side of the source code. This is just like if you're used to like visual code, because most people know that one now, being it works on almost everything, Linux, Mac, and all that stuff. And it's free. So programmers are notoriously cheap. So there you go. So what you do is you just put a little check mark there, and that means breakpoint. So that's where it's going to stop running your program, right? So I can say, okay, stop at this subroutine, stop before I return, and stop just before I enter the program. Because as you guys are hopefully programmer types, you know, main is the start of a C program. So it always has to be called main. So that's why I put main in there. The subroutine over here, I'm going to break it somewhere in the middle just for fun. So what I've done is I've set up a bunch of breakpoints. So these are points where I want to stop and look what the state of the program is. And I'm going to hit the start button. It's going to go as fast as computers go to the first line. So it's like blink, right? Now it's at that curly brace. So I'm at the curly brace. What do I see? Well, I got no variables. I got a stack, but it's pretty boring. I got a start in there. That seems magical. That's underneath the covers, right? Every OS4 program has a start symbol called _start in it. And down here, you gotta scroll this up. I see the line 11 and the assembly language right beside it, PowerPC assembly. So we got any PowerPC assembly people in the audience? Anyone? There's one. There's one. See, you know what that means then.
Give me a few hours with it. I can figure.
No, STW store word.
Yeah.
MFLR move from the link register.
Got it.
Right. I got that one. STW store word, boring. MR, that's a shortcut for move register, I think.
Right.
Right. Okay. See, I kind of know it. I can fake it. It's much easier working C.
Maybe for you.
Maybe for me. Yeah. Some people love assembly, and that's all they live for it.
Yeah.
Some people live for it. I suffer. I'm a little bit higher than that. So I'm going to hit start again, and what it'll do is jump to the next breakpoint. And something interesting happens. The output, like if you have any standard IO, it goes to a window, and the little window will just capture all the output and all the input, right? So I'll just pause this. Okay, so the reason that he opens a brand new window is because piping stuff in Amiga is tricky. So instead of just trying to pipe it, he just opens a brand new window, throws the text out. Now in Visual Code, it'll have a little terminal window, and you can see the output there, but every debugger's got that kind of feature. Just wanted to point that out. So I'm going to put that in the background. So now I'm in the subroutine, right? And now you have a choice. I can hit start again. I can hit step over or step into or step out. So with a subroutine, you might want to step into the subroutine. That's why you have step into. You can go into the subroutine, or you can just step over it. You can make it all run very quickly and step over top of it. So that's what I wanted to point out.
So it runs the code in the subroutine, it doesn't skip the code.
Yeah, but I can skip it if I want, because you know, in a big program, you're going to have thousands of subroutines.
Yeah, and there might be something you're trying to avoid.
You don't care about 99% of it, right? You want to step over, step over, step over, step in, step out. You're
So, but the step over is skipping.
no, it runs the code. It just steps the debugger over it. It still runs the code. Yeah, you're just not looking at it. You're not interested for whatever reason, right? That's the power of the debugger. And it's also the frustration of it because it's so slow. Usually it's very hard to find bugs this way, but you need it sometimes. I'm going to step in. So now I'm in the subroutine, right? And I just want to maybe go a couple more steps. So I'm going to go step, I'll just do step over, and I'm going to hit another step over. And it's doing something with that line. Oh, there we go. Now I stepped over it. There should be an output. It says subroutine over here. There is. Woohoo! See, it's a subroutine because it did a print. And then I'm going to go, okay, do a couple of floating points. And that's why I want to pop up the registers. So you got all the usual PowerPC registers there. All the flags, all the wonderful stuff. Of course, everyone knows what all these are. Right? So MSR, I think that's machine state register. That's one of the most important registers in a PowerPC. Tells you what state your machine's in. And each of those bits in that hexadecimal number, very, very important. And that's where you whip out your reference manual and figure out what they mean for your particular core. What's that? IP or LP? What is that? That's an I, instruction pointer, I think. Yeah. So that just tells you what instruction it's on. GPR is general purpose register.
You can't click on any of those, get any.
No, you don't get help. You gotta know what you're doing. You want help?
Yeah.
Cry.
Like,
Cry.
text to something with a translation or something that.
No help for you. No.
You
And-
will learn hex code.
And there's 32 registers on this particular core. Is it always 32 with PowerPC?
I'm sorry?
Is it always 32 registers with PowerPC?
No,
Sometimes they're more or less.
there's not less.
There's more.
There can.
Okay. I don't know.
The ISA itself does not specify.
Yeah.
A fixed number of GPRs. There's a minimum number.
Minimum. Okay. So you got a minimum number. So in this particular CPU, we got 32.
Well, the other issue is that in some cases, if you, depending on the instruction, there's only so many bits you can use for the ID of the register. So kind of by definition, you're limited to a certain number of bits, which limits you to a certain number of registers.
You know, I never thought about that because I just don't care.
Well,
Because that I have to address the register. But you're right. You have to have everything in a computer has to have an address,
that's right.
including the registers.
Right. So.
Yeah.
the
I never
architecture-
thought about that.
There's reserve bits, there's reserve bits in the
Yeah.
I don't remember what the PowerPC equivalent of the program storage word is, but whatever that is. And in the future, what will happen is there'll be a flag that will be set, and it'll actually enable you to have 2 different flavors of a whole series of instructions. So that in theory, you now can have more registers or whatever else because we've expanded the fields.
Oh, brother.
You know,
So,
that's really messy, but Power ISA is messy.
so for those who can't hear on the internet, he's saying, basically you can have an option added to the hardware architecture that you can have a bit that flips you to another set of registers or another set of instructions
The lab.
or whatever, right? The hardware people are mad.
Exactly the same.
Oh, the opcodes are the same, but entirely different functions,
Yeah.
potentially.
Well, I mean.
Potentially.
Yes. Yeah.
Potentially,
The
yeah,
fields can
yeah.
be-
Yeah, you can remap them on a flick of a bit. Yeah,
Not
yeah,
everybody do that, but it's possible.
it's possible in the hardware universe. Yeah, because in software we have it so easy. We need more complication. So that's okay.
Are you blaming part with that?
I don't have to blame them. They are the source of all evil. It's a given. It's like the sun will rise.
Nature.
You don't like it, run your code on a loom.
And there's the defense. Anyway.
As opposed to the, write it yourself.
Yeah. You don't like it, run it on a loom, he says. Anyway, there's the floating point register. We got floating point registers, a whole bunch of those too in this monstrosity. There they are, the FPRs. And I just wanted to show there should be a 3.14 in one of these registers. I hope. That's another thing that you'd never get unless you turn off optimization on a CPU. Optimization has this habit of just taking all your code and reducing it down to one line. You have this wonderful big program and it just comes out as very, very short because the optimizer in your compiler will simplify everything for you, right? Sometimes you don't want that. Because you want to see, you want to step by step, right? You want to see the 3.14 in a register. And you're looking at, where is it? Oh, the compiler probably optimized it away, right? It's not there right now. So I put in a couple volatile statements in an attempt to stop it from optimizing so that I could at least see something in a register. When you put volatile, that means don't optimize it, more or less. Leave it alone, right? Optimize or skip it. So you should see, where is it in here? Oh, not today. Huh. I thought I got a 6 point something in there. I did one run. Anyway, maybe I have to go to the printf. That's what it was. I think that's what it was. I had to print it and then it appeared in a register somewhere. Because I had this running when I was creating the demo. I don't see it today. Huh. Well, okay, fine. I was hoping it would appear in there. Anyway, I got the printf here. Oh, minus nan. Oh, that's interesting. Huh. Oh, that's interesting. It's slightly different behavior. Huh. Anyway, we'll ignore that for today. Maybe with the debugger, we could figure out what it is. So I'm in the subroutine. I keep hitting step. Well, now I want to step out. I don't want to go in there anymore. So I step out and it immediately jumps to the next breakpoint, which is a little check mark. So you can see it printed loop 0, 1, and 2 because I didn't put any breakpoints in that loop. So it just ran the code. I stepped out of the subroutine, it ran all that code, ran to the return 0. So that's what you expect a debugger to do. It's very good. And then I hit step over one more time and it exits the program. Poof, it's gone. It's out, see? There's nothing left. There's a console for the debugger. There's the stack trace didn't do very many interesting things because I only have one subroutine. But that's the basic gist of it. And there's another mode to this thing. You can put it into this split window mode where you get all of the windows all at once in different spots. If you like that, if that's your thing, I don't know, might be your thing. I'm not judging.
Is there a live look at variable states in this? Did I miss that?
Variable states.
Yeah.
Let's look. Do I have to load it again? Maybe. Oh, wrong keyboard. How many times am I going to do that? 2 keyboards, you hit the wrong one 50% of the time.
Changing the variables on the fly.
Oh, to set the variables. I didn't notice to be honest. I haven't done that in a long time. Let's see. We got a local. I don't see an option to do it. Version 3. Because yeah, you want to change I to like 47. Yeah. For some crazy reason, because you want to. Yeah, that's another feature that debuggers usually have. Yeah, usually because you want to perturb it, make something happen that shouldn't. Yeah, I understand. No, I didn't see that option when I was working with it. There's a show globals, which is kind of neat. There's not many globals on this one, but 0 globals.
Does it give you anything else that you'll break inside root?
Let's see. Step. We hit start. Where am I? There we go. I'm in the loop. Okay, I'm in the loop. Stack trace. So yeah, it knows I'm in the loop. Variables. I got I. Disassembler, of course, registers. What else would you see in the loop?
Oh no, I was just wondering if the variable was
Oh, yeah, the variable I is there.
Where it stopped, and if you have like, you can't like double click it or like that.
Yeah.
On the variable viewer.
There's variable, now it's 2. Yeah, so you can see the variable, the local scope. It does do scoping properly. Yeah, yeah, like it should. Yeah, so it's a darn good start for a debugger. Like you can now go add and add and add more features, right? Very good
This
start.
was built from scratch.
Yeah, he built it from scratch.
Based it on GDB or anything else?
No, no. We've tried porting GB many times, and it always runs into troubles. Always into troubles. I'm always told it's spaghetti code, but I've never looked at GDB, to be honest.
Me neither.
So I don't know if that's a true assessment. Because a lot of people hate GNU software in general. So.
I manipulate register.
Hmm?
I manipulate register.
That was the question. Yeah, I don't think you can. I didn't notice an option. No. Usually right mouse button or something. No. Not right this second, although we could add it. And then there's a console that it keeps too, which is nice. So you can see all the steps that it's been doing. What you were up to. It keeps kind of a running log of what you've been up to. So yeah, it's a very simple debugger, but like I said, it works well. Works well, especially since he fixed the operating system to make it work well.
That's impressive.
That is very impressive. I think that's very impressive.
Incredibly impressive.
Yeah. So there was a
Given access to the source to do that, obviously.
Yes.
Yeah.
yes,
So you guys,
yes, from you guy. That's right.
you guy.
Yep. Yeah, got him in the club. He's all good. So because I really wanted a debugger and other people did too.
Yeah.
Now Elfkill did his own thing. I did not help with the testing in any way. I was very lazy, but opened the doors, right? That's the secret. Push it along, yeah, that kind of thing. Remove barriers.
Yeah.
That's all I did. So I didn't get any credit, but that's fine. I don't need it. There's a lot of, actually, there's a good list of credits that came with Spotless. I should point out. There was I think Paul was in the list. Actually. Were you involved with this?
What? That's?
Yeah.
No.
You sure? Don't lie to us.
I know.
Ah. Where is? What do we have? Oh yeah, read me. Actually, that's garbage. Do this. I think it's at the bottom. There we go. So we got Castle, Frieden, Wenzel, Niles, Ninja DNA, and Jamie Kruger. Hey, shout out to Jamie. There you go. What's next on our schedule, by the way? We have lunch now, or no, in an hour? Is that now? Now. Okay. I don't have the schedule handy.
Let me pull that up.
One moment, please. I think we have the next one at 1. I hope. Or did we run over it?
So we had debugging going until noon.
Good. I gave myself lots of padding.
We had lunch. And then after lunch, we have the NVMe driver.
NVMe, yes. So good.
Then we have you with DMA engines.
Me again. Okay. Well, sorry.
So we've got some time.
Till 1?
Yeah.
Okay, so
So if you, I mean,
if there's cues, because lunch isn't here yet, questions, keep them coming, right? Anybody want to actually try this thing? Because
Yeah, actually, can I get it on OS for Debug?
yes, just download it there, but you can't have the secret kernel and elf
I've
file.
already got this. Kernel.
Man.
I've got, as a matter of fact, I've got newer versions of Secret Kernel, and it was your fault. You gave them to me.
Yeah. Yeah,
Thought you could trust.
I didn't know that this change happened. See, I didn't know about the change.
Change,
Yeah,
now
This-
that you do. Shit.
it's even better.
People online can't hear the back and forth.
Yeah,
So
true,
let's
true.
try something.
Uh-oh.
Plug your ear in case I blow us out. Right. But last night I found out that they've got a new sound system, new PA system, and wireless mics.
Yeah, yeah.
So I'm gonna turn this guy on, and well, I want that to be on.
Okay, I'm just keeping my thumb on the mute button.
Sound here will be better for people online.
Yeah, I know,
So,
I know.
hello. Can the people online hear better when we use this microphone? Please comment in chat.
Wait for it.
Wait for it.
Takes a minute to get out there.
The speed of sound instead of light. I can hear good either way.
Wow.
Well, maybe it was an individual problem and not a group problem. There's a volume knob on your PC that you can turn up.
Steve, just real quick, the version of Spotless that we should be using.
Yep.
The most. Oh,
It's like a year old, right?
yeah, the most recent version that's publicly available is 2.21 from November of last year.
That's the
Okay, so
one.
There haven't been any changes. That's
No.
what I want.
That's what you want.
Thank you, sir.
Yeah. Yeah.
I want to take this from you for it, Laura, so many years.
Because it wasn't stable enough to use because we needed some fixes in the OS. So that's one reason I didn't want to show it off. The other reason was I didn't know how to use it yet.
I'm curious.
Oh, okay. Okay.
They could hear better.
Mike. I have a microphone for an unknown reason.
I don't know either because you have the main mic. These are for the audience. The wireless mics are for the people in the audience.
You have that statue in New York. I kind of look like her, hey? Any other questions? No? Okay, I'm gonna.
I don't know if we talked about this. Someone had asked about if Spotless is on GitHub, do we have a
Yep.
a link to that? Apparently it's not readily findable.
Really? I found it, no problem. Okay. Weird. I don't want to stop screen sharing to go look for it right now.
Like Kelly says, let somebody else do it for you.
Yeah. Can one of you pick it off GitHub? Anyone?
What do I do?
Anyone? Find Spotless source code on GitHub,
You want a URL?
please. If you just type elf kill Spotless Amiga, you're not going to miss it.
The trick is elf kill Spotless Amiga.
You gotta have unique keywords. Yeah, you can't type Spotless. You're gonna find all sorts of weird stuff, right?
The cleaning thing.
Yeah.
If you can. Here, I guess we just throw that in chat.
It might be in the README file. I
What
never,
is simple debug?
that's another version of Spotless without the GUI.
It's literally github.com/alpil/spotless, but. Okay, here, I'll put it in Otherworld or the AmiWest channel or what do you want to do here?
Where do you want him to stick it?
Now,
I thought we'd stick it in the chat, but. If the folks online have a super secret meeting spot, we can put this in, that's cool too.
You gotta watch out. He has sidewinders. Sparrows. Nice, nice.
Where's your badgie? Badgie.
He's right there in front of you.
Nothing.
Thankfully, I dumbed him down because I didn't want the carnage. So
Badgie does. Hello world.
yeah. It's not too bad, but we can make him worse. That's not hard.
Badgie is a murderous. What is this badgie? I'm not understanding. Star Trek Lower Decks. You say that like I'm supposed to know what? Well, because it's an awesome show. It's a show and I was talking about a game. How am I supposed to know that? You're a geek. Not that much of a geek. You're a fucking huge geek. Hey, no fat jokes. Only I get to do that. Okay, how about geek of epic proportions? That's still something. Geek of incredible level. Okay, I'll take it.
It's from Elf Killer.
As long as they don't go to the nerd.
ALFKIL.
Badgie is a character on a Star Trek, animated, Star Trek Lower Decks. It's an animated Star Trek? Yeah, and it's hilarious as hell. Is this
Yeah.
on like on YouTube? What is this? It's on Netflix. Oh, no, on
I think it's Paramount.
Paramount.
Yeah.
Oh, it's a proper show. Oh,
Yeah.
yeah, it's canon.
It's like year 6, season 6 or 5. I don't know.
Let's try this. And it's.
But which show?
Is it appropriate for children or not?
Barely. If they're.
Especially Badgie.
The original series. She loves it. I'll do it. She's Master 19.
Oh, she'll be fine.
Well, no.
18. You're legally adult. So.
Well, yeah, but
We
it doesn't matter.
Well, yeah, it does because we can't be sued.
And-
That's your thing. That's your thing. You might want to preview it.
I showed her some of the next generation stuff and she was like, she didn't like it
Okay.
because she thought the card was a win.
Well, they rip on next gen hard.
I
And
like it.
Does-
I thought it was great.
Does she like Voyager?
She hasn't seen that and I wouldn't show it to her. I think it's. So, but she loves the original series. Like she absolutely adores it. Oh, I think this is great. And she Shacker's great. She thinks,
Yeah.
She really loves the characters.
Yeah.
Did you want to do the NVMe early?
nope, because it's remote. I'm not doing it.
No, you had your name on it, so I assumed you were doing it.
Enom is doing it, isn't he?
My name's on it.
Harold.
I put that in the spreadsheet. Yeah.
Oh, wait, no, I'm sorry, you're right, I'm reading this wrong, the DMA, not NVMe, DMA.
Yes.
Do we want to do that before lunch or keep it on schedule?
No, let's keep on schedule. Yeah. Take a break. So we can probably turn this off if there's no other questions.
Good afternoon, everybody. Can you hear me?
Yeah, I can hear you here at my house. I don't know if they can hear you at the Devcon. Jerry, can you hear Harold?
Yes, we can hear.
Okay, then let's start. Yeah, well, first of all, yeah, thank you for having me. I was a bit surprised that I got the invitation from Steven, because I'm not a long time Amiga developer and I'm also not a software developer at all, but yeah, here I am giving a presentation about software. So let me see how this works over here. So I'm going to start with a small introduction, and then I'm going to give a small overview of the basics of NVMe, where to start with driver development, and I will show you a bit about the architecture of my driver itself. Then I finish the presentation with some performance figures, and if there are any questions, then there's still room to answer them. I'm not sure, it is now 10 past 10, my local time. So I'm not sure if there's any padding. but well, let's see how it goes. For those who do not know me, my name is Harald Kanning, or Harald Kanning, also known as Geen Naam. Geen Naam is Dutch for no name. I simply did not have any inspiration to come up with a catchy nickname, so that's where Geen Naam comes from. You might know me from the high definition audio driver for OS4, or this driver, the NVMe driver. And if you still don't know me, you might know me from my strong opinions on Amiga websites. So why did I develop the NVMe driver? Yeah, it's my passion to play around with new technologies. So yeah, when I bought my X5K, I didn't really want to search the marketplaces for some used old audio card. I thought, well, I want to use a card that I can buy in my local store, so why not develop a driver for it? And that's what I did. And yeah, well, when the driver was mature enough, I was looking for new opportunities. And yeah, there was this nice PCI Express slot available in my X5K. I don't run any other operating system, so it is, yeah, it was currently unused. So yeah, why not make use of it? So basically the only real yeah, I think that I really wanted was that there must be a specification available. Without specification, I need to reverse engineer drivers or look into Linux drivers. That's really not my thing because I'm not really a software developer. So yeah, then I thought, why not start with NVMe? Because NVMe will eventually make SATA obsolete. You can already see it on the PC world. Laptops, but also desktop PCs are not shipped with DVD drives anymore, and it's just a matter of time that also the hard disks will be replaced with NVMe disks. So that's where the idea came from. Now, what is NVMe? NVMe is short for non-volatile memory express. And well, to be honest, this name doesn't really cover the standard itself because, well, non-volatile memory can be anything. It can be an optical drive. It can be magnetic media like a standard hard disk. But in this case, it is really targeting NAND flash-based memory. And the reason for that is shown in the image in the right bottom of the screen. In the upper part, you see the average setup for a SATA hard drive. You have your expansion card that you can fit into your PCI or PCI Express slot. It will talk to an advanced host controller interface, so your SATA controller. And on turn, it will talk to your SATA hard drive. And if you look at the top, you can see that yeah, the delay between your PCI interface and your host controller interface is a single-digit microsecond. And between your advanced host controller and your actual hard drive, it is about 2-digit microseconds. And this all doesn't matter because the real delay is between your SATA controller and your platters, your optical storage. And that's in the milliseconds, so a factor 1000 larger than between your host controller, your SATA controller, or on the PCI bus itself. So yeah, it's really redundant. It doesn't matter. But this all changed when hard drives got flash memory instead of this optical storage. So suddenly, the delay between the SATA controller in your hard disk and your storage of flash memory was in the double-digit microseconds. So now the delay between your SATA, your advanced host controller, and your SATA hard drive was certainly dominant. So that is basically the reason why they had to invent a new standard to to fully make use of the power of NVMe or of flash-based storage. And that's basically what you see at the bottom of this picture. Again, you have the PCI Express interface, in this case PCI Express, but there is no controller in between. It directly connects to your drive. And that overall, that is a lot less delay, and that will ensure that you can get a lot more performance from these kind of drives. So that's basically the reason behind the introduction of NVMe. Now, NVMe was also designed with multiprocessing in mind, but I'll come to that later. And it is still block-based, so you do not use direct addressing, but you still address blocks like normal SATA drives. And there's also some kind of persistent rumor that SATA drive or NVMe drives need 4K logical blocks, but that is not true. What NVMe drives need is 4K host memory pages. So your whole memory management on your host needs to divide your DDR memory in 4K pages. And well, that is true for Amiga OS. So there's no reason why NVMe shouldn't work on the Amiga. So that's why I wrote this driver. Now, NVMe is a very layered structure, and the reason for that is that they want it to be as flexible as possible. So your actual flash memory is called a namespace, and this one is part of what they call an NVMe set, but an NVMe set can contain one or more namespaces. There's not really a restriction to that, but for now, I don't see a reason why they use it, and I haven't seen on any drive that they use multiple namespaces, but it is a possibility. And an NVMe set is on its turn part of an endurance group. Now, I can understand why you want to use multiple endurance groups, because I can imagine that you want to mix, for example, NAND flash with NOR flash, and NAND flash has a different endurance than NOR flash. So I can imagine that an NVMe drive can contain two endurance groups, one with NAND flash for your bulk storage, and one with NOR flash, for example, a bootloader or something that needs to be persistent for a long time, even when the drive is not powered. And the endurance groups on their turn are together with a controller part of a domain, but here again, an NVMe drive can contain different domains. And these domains connect to a port, and a port can be a PCI Express interface, but it can also be an Ethernet interface. And is internet following my speech? Because I see a delay in what I present and what I see on YouTube.
Yeah, don't worry about it. You're coming through perfectly fine, Harold.
Oh, okay. Yeah,
Hey,
it's distracting. So I now will shut off my YouTube stream then.
Yeah, that's the best thing to do. It's a very long delay on YouTube. One question about the endurance groups. In the endurance group, do you know if you can control the oversubscription amount?
Sorry, D?
In the concept of the endurance group for an NVMe, when they're created, do you know if that's something, is that like a drive level feature, or can a user create
No.
oversubscription?
No. It is really something that is created on a hardware level. So it's not configurable.
Okay, got it. That makes sense. Thank you.
No, so what I show you here is simply an overview of how NVMe is constructed, and how flexible it can be. So you see namespaces, sets, endurance groups, controllers, domains, and ports. And the standard doesn't really have a restriction in how you can combine these into an NVMe drive. Yeah, the good thing is you can configure it according to your needs as a hardware manufacturer. The bad thing is then I have to write a very complex driver to support it all. But what I've seen so far with all the drives that I've tested is that all the drives simply contain one of each. So one namespace in one set, one endurance group, one controller, and obviously one port, because we only have one PCI Express interface. But I can imagine for enterprise kind of systems that you want to have something like a fail-safe connection with a crossover PCI Express port, those kind of things. But yeah, I just want to say the standard allows it, but the commercial NVMe drives don't use it. They simply use one of each. So how do you communicate then with the host? I mean, we have this port, the PCI Express interface, and how does communication work over the PCI Express interface? Now that is basically the same as every PCI Express type of card that I've seen so far. Doesn't matter if it's HD audio, a graphics card, or in this case a storage card. You all have to yeah, what is the word in software land? Not really declare, but you have to create ring buffers in main memory. So you simply create in your DDR memory buffers, which are used to communicate. These buffers do have certain requirements, like it has to be aligned, in this case, on a 128 bytes boundary. Yeah, but that can be different for each type of PCI Express card. But in this case, it was 128 bytes. You need to create what they call a submission queue. In this queue, you simply post the commands that you want to send to your NVMe controller. And when this command has been processed, the result will be stored in the completion queue, that is the C queue. Now, they make a separation between the administration side of the drive, so everything concerning configuration and initialization of your drive, and between transferring data to and from your flash memory. Because for the flash memory, they use what they call an I/O submission and completion queue. And the funny part is that the standard allows you up to 65K of those kind of queues. And the reason for that is to support multiprocessing. What you can do is you can assign each of such a queue to a different CPU core. And that will increase the overall throughput of your drive, because there is no single management processor needed to control all the I/O. Each core can access your flash memory individually. But there is also no restriction on the amount of submission and completion queues. Personally, I don't really see an application for that, but if you would like to, you can, for example, and you can see it over here, you can, for example, in one IQ lane of IO lane, you can have 2 submission queues where the answers will be posted in one completion queue, for example. So it's all very flexible. But my driver will use the most basic variant because we don't have multiprocessing yet. So just one administration queue and one I/O queue. Now, once you've posted your command in the submission queue, and that can be multiple commands at once, you need to ring the doorbell. to let the NVMe controller know that there's new commands available. It will not check it automatically by itself. It will simply ring the doorbell. You have to ring the doorbell. And the doorbells are located in the bar space of the drive. So it's not available through any of these queues, obviously, but you have to write directly through your PCI interface to the bar 0 region. And in a similar fashion, when you have handled a message in your completion queue, you have to let the NVMe controller know that this entry is available for next completion message. So you again have to ring the doorbell. But this is also very basic when it comes to PCI Express cards, because one way or another, they all work in a similar kind of fashion. Now, these buffers in main memory are DMA buffers. So the NVMe controller itself uses DMA to directly access these buffers. Yeah, that means that your buffers also needs to be contagious, so no gaps in between. And if I, from an host side point of view, want to access these buffers, I also have to do the cache handling. So if I write something to this buffer, I need to flush out my cache to DDR. And the other way around, if I want to read from this buffer, I need to flush out my cache and make sure that I get the latest information from my DDR. In case of an X5K or probably the A1222, this is done automatically because those two systems are fully cache coherent. In case of a SEM 440 or 460, you do have to do this manually. So you manually have to flush the caches. This is important to know when you want to design these kind of drivers. Now, another feature of NVMe is that it can use MSIX interrupts or MSI, but the power of MSIX is that I can assign each of these queues to a different interrupt vector. So no need to handle the buffers in some kind of interrupt routine to see which one of the queues was causing the interrupt. No, you can get a dedicated interrupt for each queue. But, and that's a big but, unfortunately, Amiga OS doesn't support MSIX, and it doesn't even support MSI. Currently, at least what I know, I don't have access to any beta kernels, but what I know is that we only support emulated pin interrupts. And I don't have a clear evidence of it yet, but sometimes I have the feeling that these NVMe drives, are not always fully supporting these legacy kind of interrupts, because, well, if you want full speed, you use MSIX. So who uses these legacy interrupts anymore in combination with these kind of drives, except for OS4? So that is why I've decided to not use interrupts at all. So in my latest driver, I simply pull the completion queues with a wait function, of course, not to have my processor load at 100% all the time, and hopefully these drives that do not behave very well with my driver now, maybe now work my driver. I don't know yet because my new driver is not in the field yet, but it is at least my suspicion that something is going on with the legacy interrupts. So how does a message look? What does a message look like? In the top left corner, you see a submission command. This is what they call a command format. It is a 65 64 bytes command that consists of the opcode, so the actual command that you want to execute on your NVMe drive. There is some configuration if you want to fuse multiple commands together into one command. This one is also important. This is if you want to use so-called physical region pages or a scatter list. Now, an SGL was added later to the standard, and up to now, I haven't seen any drive which supports this yet. So my driver only creates PRP lists at the moment. And then there's the field that's called the command ID, and this is just a number. So this number will also be mirrored in the completion queue to match your commands and to see if it's already been completed with within the NVMe controller. Yeah, the second field is the namespace ID. So this is yeah, the namespace that you want to target, but up to now I only have found drives that have one namespace. So this one is always one in my driver. It's not always one in my driver, but currently I cannot support multiple namespace simply because I don't have the drive to test it out. Some command specific fields, and then a metadata pointer. This is also not currently in use in the drives that I have in my possession, because I can imagine that again these enterprise drives want to write some additional information to the data that you write, maybe some CRCs or these kind of information. So yeah, there's a pointer field to it, but in my driver is currently not used. And then we come at the interesting part, because now we come at the data pointers. And the data pointers can either be this field in case of a PRP, and then the first 64-bit pointer points to the first 4K memory page. So your host memory page, your 4K memory page of your buffer. And the second one can either point to a second memory page if only one page is crossed, if one page boundary is crossed, or it can point to an complete physical region page list. And this is actually the hard part. So what you have to do is, well, you create your buffer in main memory for example, data that you want to transfer to your drive. And now you have to dissect it in a list of 4K memory pages. Yeah, and it really depends on how the application that is calling my driver has declared its buffer. If it's contagious, then so in one piece with no gaps, then it's easy to create a list. If not, you have gaps in between, then yeah, it's a bit harder to create this list. But yeah, in the end, it can be an extensive list, and it takes quite some CPU power to create it. Now, in case that you have a drive with an SGL support, the scatter list, then you can use the OS4 features to get the scatter segments. Yeah, but like I said, currently the drives that I have do not support SGL. So for now, this is not implemented. It is also an option to the standard. PRPs are mandatory, so even if drives support SGL, they will work with my driver. Now here on the bottom side, you see how an completion message looks like. It's only 16 bytes with some specific entries for the command that you've sent to the drive. The command ID is here, so this is the same value as, well, you've entered here, and this is just some kind of follow-up number that you can create. There are no restrictions to it, except that you cannot use what is it, 4 times F? That is reserved for some reason, but otherwise than that, you can create your own numbers. And this one is also very important. This is the phase bit. The phase bit shows you the head pointer of the controller. So each time when the controller posts a completion entry in your completion queue, it will flip this bit. So you can check with the phase bit, where the head pointer in your ring buffer is. So I can imagine that this is a bit technical. I'm not sure if everybody can follow, but well, if you want to know more, just read the standard and everything becomes clear. So where do you start with writing a driver? Now, first of all, you need to be able to connect your NVMe drive to your Amiga. And yeah, since we don't have an M2 slot available, we need to use a converter card. But that is not an issue because, well, if you check Amazon or these kind of online shops, there is a wide variety of all kind of converter cards, ranging from an ×1 interface here in the lower corner up to the ×4 interface that will bring you the most bandwidth. So yeah, it's actually easy to connect it to your X5000 or X1000 or whatever. Since we are restricted in PCI speed, yeah, a heatsink is not really required because these drives start to generate heat when the transceivers on the NVMe cards are running at a very high speed, and we are currently limited to 5 gigabits. So yeah, we should not be worried of an overheating drive. So no heatsink is required. There are cards available with multiple slots and an onboard PCI Express switch. Yeah, they should work, but I haven't tested it, so no guarantees over there. And yeah, you also don't need to worry about the link width because the X5000 will auto enumerate and they will negotiate the link speed that is common to both and the link width that is common to both. But I do sometimes see issues with enumeration, and yeah, that is an issue of my X5000 because the exact same converter card with the exact same NVMe drive does enumerate correctly on my PC. So yeah, there's something that we might look at in the future if possible. So then how do you start developing your driver? And yeah, that is obvious. First start with reading the specifications. In this case, the specifications of interest for NVMe are the base specification. The latest version is version 2.0C. That is also what my driver is based on. And there is a specific command set specification for some specific commands that are not listed in the base specification. And yeah, finally, you also need to be aware of some PCI Express registers. So you also need to read the PCIe transport specification. But that's it. All the information that you need regarding developing a PCIe driver from an NVMe perspective is in these 3 standards, these 3 specifications. So you do not need any prior knowledge of driver development or the PCI Express interface. Everything you need is here. So now you have all the knowledge about NVMe. So how do you start an actual Amiga driver? And what I did was I simply started with a shell application. So not with a driver itself, but just an application that I have called my NVMe probe. And yeah, in this NVMe probe, yeah, the first thing you need to do is you need to find your NVMe drive. Now, there are two ways to do it. You can search for device ID and manufacturer ID, but then you only get support for a specific specific drive. What you also can do is you can search for the so-called BCC, SCC, and PI. So that is the base subsystem, the what was the SCC again? That was the something kind of like a subsystem ID, and then you have the PI, that was the programmer interface. And if you search for that, and in this case it is, I think if I remember correctly, the BCC was 1, the SCC was 8, and the PI was 2. So if you search for 10802 hex, then you will find any NVMe card in your system. Now, after you find your PCI Express device, it's time to start implementing your ring buffers because you want to communicate with your drive. And then you can set up your card according to the base specification. There's a recipe in it to make it easy for you in the standards. And well, after you have your administrator queue, then you can start to discover your device. And as you've seen, it is a layered structure. So yeah, it is really like peeling an onion. You start with discovering your drive, then with your controller, and finally you will see the capabilities of your fabric, of the namespace. And if this all works, yeah, then it's testing time. So in my case, what I did was I wrote a small function that wrote a small buffer to the fabric, then read it back and compare the results with what I intended to write. And when it was a pass, then I know that I've configured my drive correctly and that all the queues were working. And this is what the output of my probe looks like. Here on the top left, you can see anything concerning the PCI bar space. So that is, yeah, if you ever opened the PCI tab in Ranger, for example, and press on a device, you will know what a bar is. And you can see these kind of values. This bar gives you information about vendor and device ID. This is the address of the bar itself. You can discover your link width, in this case ×4, because it was connected to my X5000. And well, that is running at 5 gigabits. So the overall speed, the link speed, is enumerated at 2 gigabytes. So far so good. So then I could start peeling the onion, get the supported NVMe version. So in this case, for this drive, it is 1.4. Now, like I said, SDLs were added later. It were actually added at 1.4 of the standard, but still this drive doesn't support it. The maximum queue entries, so the maximum length of a queue, is 256 entries. But for the administration queue, I've configured it to only 2 deep. I don't need more entries because it's just waiting for an answer. So why do you need more queues? I don't need the speed. These queues needs to be in one continuous piece of memory. So this is also what the drive tells me. The standard allows to use some padding space, but in this case, I haven't come across a drive that allows this. Everything needs to be one piece of memory. The drive even tells me that my worst case timeout time is 5 seconds. So if I implement a timeout, I need to accompany for 5 seconds because some commands can take 5 seconds. Well, this is something that's not so interesting. Doorbell stride is also not interesting. And here's the host page. Like I said, NVMe really needs a minimum host memory page size of 4K. Well, that is what Amiga OS supports. But I have seen drives that support larger memory pages. Now, I have no knowledge about operating systems, so I do not know if there are operating systems out there that support larger host memory pages, but some drives support it. So, yeah. So once you have discovered the NVMe controller, you can go on with discovering the controller right before your actual flash memory. Now, in this case, it's the same manufacturer as the manufacturer of the card. So we are talking about a Western Digital card with a Western Digital NVMe controller. You get all kind of information like serial numbers, firmware version, all very interesting for later, but not so much for now. And this is also a very important parameter, and that is the maximum transfer size that an NVMe drive can support. So if I would, for example, want to transfer 2 megabytes at once, then I cannot do it with a single command because the drive tells me, no, I can only transfer 1 megabyte with one command. So I have to split up again a command in 2 commands to be able to transfer 2 megabytes. So there's a lot of splitting going on. I need to split the complete transfer size in smaller sizes that is supported by the drive. And then I need to split the smaller size again in physical region pages. So in a complete list of 4K memory blocks, pointers to 4K memory blocks, and present this to my drive. This is also not very important. Here you can see that the drive only supports 1 namespace, but yeah, like I said, all the drives that I have in my possession only support 1 namespace. And I can imagine in the future when yeah, the sizes of drives will increase, that they want to work with multiple namespaces, like a kind of paging feature, but for now that is not used. There's also something like a volatile write cache, where you can use onboard memory to cache transfers. So in this case, it means that you write something to your drive, but it is not written actually to your flash memory, it's written to cache. And this has the advantage that it will extend the lifetime of your flash, but it has the downside that if you have a power out or whatever, you switch off your computer, then it could be that you corrupt your drive because the data was in your cache and not in your actual flash memory. So for now, I've switched it off. But what I do support is the so-called host memory buffer. NVMe drives come either with DDR memory on board or not. The more expensive drives do have it, and they use it to increase the throughput of the drive. But in this case, this Western Digital drive didn't have an onboard DDR memory. So then NVMe has the option to use a bit of the host memory as a write buffer. And my latest driver does support it. If you connect an NVMe drive without embedded memory, then I will use a 64 megabyte host memory buffer to provide this additional throughput for your drive. yeah, the downside is you will lose 64 megabytes of your main memory, but well, it is like it is. And finally, when you've has discovered your controller, then you can also discover the capabilities of your namespace. In this case, it is a 1 terabyte drive, so the namespace size is 931 gigabytes, because a kilobyte in these kind of storage drive is not 1024, but it is 1000. So yeah, this terabyte, well, it's actually less than 1 terabyte. The way we are used to it. And this drive also supports 2 different LBA formats. So the traditional 512 bytes, but it also supports the larger 4K LBA format. Now, we cannot use this on OS4 yet. And the reason behind it is because Media Toolbox doesn't support it. So I actually have a small tool that can reformat the drive from 512 to 4K. But as soon as I present this to Media Toolbox, I cannot create partitions anymore because, well, it's not supported. Now, you don't have to be afraid that you buy a drive where the default value is 4K, because all the drives come pre-formatted at 512 bytes. So for now, there is no issue with using NVMe drives with OS4, but it would be nice if someone can remove this limitation in Media Toolbox, if possible. Now, this was a small introduction to NVMe. I think I could talk for another hour to tell you all the features about NVMe, but that's not why I'm here today. Let's go to the driver side. Now, maybe one nice thing to tell here is that it took me only 2 weekends to make this all work. So effectively, it took me only 4 days to create a program that ultimately could write and read back from an NVMe drive. Unfortunately, the Amiga side was a little bit different, because it took me in total about 3 months to get my first working driver. So and the reason behind this is because, unfortunately, the Amiga side isn't documented. So yeah, NVMe, you get the standards, read the standards, yeah, get all the information, but yeah, the Amiga side is a bit different. So what I did was, I think like every developer, you go to the AmigaOS.net wiki page and search for a driver, or at least for an example. And there was an example, and that was a RAM disk, but it was written in assembly, and not just assembly, but it was written for 68K. And that was the only framework for a device driver that I could find. Now, there was also the C implementation available on OS4 Depot. So I also had a look at that, but yeah, it's still a RAM drive. So it's reserves a bit of memory and reads and writes to memory, but yeah, it's not telling the whole story. So yeah, I had to find out all by myself. And yeah, not sure if I did it the right way, but it works. So yeah, I'm going to tell you how I did it. And if it's not the right way, then please correct me. But yeah, well, this is what I've learned. So first of all, never block your IO call that you get from the caller. And the caller can be anything. It can be some kind of benchmark program. It can be a file system, but never block the IO call. Always forward it to some kind of unit processing task and return the IO call. Because the caller can either do an IO and wait for it, or do an IO continue execution and check for its completion later on. So yeah, never block it. Another thing that I learned was understand the context in which your functions are called. Now, by context, I really mean the task. So when your device is loaded and it's configuring, it's all being done in the kernel context. So if I now here have an initialization function that declares a signal, for example, a wait loop, then this signal will only be sent to this task. And if I want to use the wait loop in my unit processing, yeah, then it will hang there because it will never receive the signal. And declaring a signal in the context of the callers when your I/O interface is also very tricky, because yeah, the caller can have declared the same signal. So be aware of the context of where you execute your functions. Now, another thing that I learned is make sure to only use resources that are available at the time. I mean, you're writing a driver, you are getting loaded by the kernel, and not all of your resources are available already. And I learned the hard way, because I first created the driver, and then I started learning about what is a kernel driver. And once I knew, and I added my driver to the kick layout, well, my system froze during boot up. And now that was not an issue on the classic machines, but in this case you have an issue because there is no way to get to your kick layout and to remove it again, other than to use an emergency disk of some sort. So be aware that you only use resources that are available when your driver gets loaded by the kernel. So my driver, I used a DOS process instead of a task, and then DOS process is very convenient, but DOS is loaded, well, I think at a priority of -100 or something. So very late in the boot up process. Other thing that I learned was you have this nice field in Media Toolbox where you can select that your file system needs to align everything at a 32-bit boundary. But apparently that was only available for some legacy reasons, for running OS4 on a classic, so on some power-up card, because for the real NG machines like an X5K, this field is ignored. And I only found out after I wanted to decompress a file on my NVMe drive, because archives like LHA, yeah, they don't use any alignment at all, so they can even access a single buffer that is aligned on a byte boundary. So what I had to do was, if I got a buffer from the caller, I had to check its alignment. If it was not aligned at a 32-bit boundary, I had to copy everything to a new aligned buffer, and then go on with processing in it in my NVMe driver. Another thing that was very tricky was the commands. I couldn't find any definitive list of what kind of commands I need to support in these kind of drivers. So you have track disk, you have track disk 64, you have NSD, you have SCSI, and yeah, which one do I need to support? So at first I implemented everything. And then did a debug printout to see which commands was used while running my driver. Yeah, so I got a list, but still I didn't check every program out there. So how do I know which commands I needed support and which not? So in the end, I simply opened a Ranger, and Ranger has this nice little feature. You can see it here on the right side. And that's the query button. So I can query an existing driver. And in this case, I queried the SATA driver for my X5000. I believe it was written by Stephen. And then I get a complete overview of what commands were supported by his driver. And that was the easy way, but unfortunately, I only found out, I think, after 1 or 2 weeks logging everything from within my driver. But anyway, I got a list. The only thing that I now need to know is what kind of SCSI commands do I need to support? And I was also not familiar with SCSI. So searched the internet and found a SCSI specification from, I believe it was Hitachi. Well, again, a lot of SCSI commands are out there in the wild, but I could reduce the list to this one. At least these are all the SCSI commands that I've seen so far. And if there are more and you know of it that I need to support, please tell me. But for now, I've only implemented this one. So what I found out is that SCSI commands are used by the file systems and by Media Toolbox, and it's basically to query the capabilities of your drive. So the manufacturer name, if the unit is ready for use, and its capacity. And that's basically all that is. That's all what a SCSI command is used for. Everything else is done by track disk commands or new style device commands. Okay, now we come to the most interesting part, I guess. This is the architecture of my driver. I'm not sure if it's visible at the Devcon hotel. I'm not sure if you're watching a DV screen or some kind of projector, but it looks complex, but it actually isn't. Here on the right side, you see everything that I already implemented in my probe. And this is basically everything that makes the device driver. So when the device gets loaded, everything starts with the ROM tag. Now, the ROM tag still has something special, so I will show it to you on the next page. But the ROM tag will point to a tag item, and this tag item contains at least 3 tags. There's also the end tag, but I didn't show it over here. The first tag is about the size of your device base. The second tag points to an initialization routine. So this is where the init of your device starts. And the third tag, the interfaces tag, that points to an kind of table of interface pointers. One pointer that is mandatory for your device is the manager tags. And if you want to have your own private functions, like in a library, you can also have a second pointer to a tag item where you point to your private functions. But in this case, I only implemented the manager tags. Any additional features that I need were done with a custom IO command. So the tag item of your device interface looks like this. There's a tag with its interface name. It has to be __ device for a device. If you were creating a library, it would have been __ library. And then there's a tag that points to a vector table. And the vector table contains all your interface functions. So you can here see it will point to an obtain, release, open, close, expunge, and also the begin and abort IO. There are also empty spaces in between, but this is information that you can easily find on the Amiga OS wiki page. So I did not have an additional sheet about this. It is easy accessible information. Now the init function needs to init the device base, so the sec list, all this kind of information. You also want to create your message port here and then so-called min list, so a minimum list. In my case, it also contains the actual initialization routines that are specific for my NVMe driver. And once my complete NVMe driver has been initialized, so I need to find the NVMe drive, initialize the queues, discover everything, blah, blah, blah. So all that you've seen in the output of my, my probe. Then finally, I have to announce my device to the mounter the mounter library. And I can do this with acquiring the interface of the mounter library and call announce device tags. This is also something that I had to find out because it's also not very well documented. Not documented in the SDK, but also not in the wiki. I have seen a mention of it in the so-called anatomy of an SATA driver written by Stephen, but yeah, it wasn't really clear when to call it. But in my case, I've called it at the end of my initialization routine, and it works. So what happens is when the mounter device is the mounter library is loaded, apparently it gets a list from somewhere and it starts mounting partitions. So this is necessary when you have your partitions mounted. Okay, this is on the bottom left corner, you have the IO interface. So this is the interface that is used by the file systems or any other program that want to access the driver. And it can do so by doing a do IO or a send IO command. And well, it enters my driver through a message port. And now I have the option to either process this IO command directly, but well, most of the time that's not a good idea because I hold up execution of the caller. So what I do again is I forward the IO message from this message port through the message port that I've created over here to a separate task for unit processing. Now you can create a task for each unit that your drive supports, but well, given the speed of our file systems, that is not really required. You can do everything with one unit if you like to. So how does a unit task look like? What does a unit task look like? Well, first of all, you need to get a message from your unit from the unit message port. Then I have a case statement to see what kind of message I actually need to process. Do I need to write something? Do I need to read something? Do I give some information about the drive, for example, the geometry or the manufacturer name? And for my custom command, I also can get the smart information, so the temperature of the drive, all these kind of informations. But in case of the read-write, I first have to check the buffer alignment, like I told before. If it's not aligned, I have to copy the complete buffer that is pointed to in the IO command to my private buffer that is aligned on the right boundary. Once I've copied it to my own private buffer or the buffer was aligned, I need to split up this buffer in all these small 4K pointers. So I need to create a physical region page. Once I have the page, the list of physical region pages, I can create my NVMe message. And yeah, then I simply send it to the IO queue of the NVMe drive, and yeah, do some manual cache handling, like I said before, because I also support the SEM460, and then ring the doorbell to notify the NVMe drive that a new command is available. And then the NVMe controller starts processing it, like fetching the information from DDR memory in case of a write, or the other way around, getting the data from flash and storing it in DDR memory. And I simply wait for the DMA to complete and ring the doorbell again that I've read the completion command, and then I can return again, reply to the IO message port that I finished executing the command. And then I start at getting the next message again. Now, it would have been very nice if there was a next message already waiting for me, but it turns out that this is not true. So this part gets executed much faster than what the file system is doing. And yeah, that is a shame, because what you can see at the end of this presentation, NVMe can be very fast on an Amiga. I can actually saturate the PCI Express interface, but unfortunately, yeah, the callers aren't capable to do so. I don't know why yet. On one hand, because they're not multi-threaded, so probably they do an IO and wait for the result, and then it's obvious that there's not a next message waiting for me in the queue, because when they get the result, they start sending the next message. But hopefully, when multi-core arrives, that might improve, and then we can get some really nice NVMe speeds. Yeah, I already talked about the ROM tag. There's something special about it. So let's go to the next page. This is what the ROM tag looks like. And like I told, I wrote a driver, started off with using a process. It was all wrong, but I only found out later on. But I still didn't know how to create a kernel module. There was no information available on any wiki page or in the SDK what a kernel module is. So finally, I reached out to Steven and to Cyborg, so Kostel, and they gave me the hint that yeah, a resident module, a kernel module is actually nothing more than a resident module. Now, well, with knowing this information, I wasn't really helped yet, because I didn't also know what a resident module was. Like I said, I'm not an Amiga developer. But in the end, yeah, if you want to create a kernel module, you need to add this flag over here. And that's all that's to it. So if you add the RTF_cold start flag, then you have created a resident module. Yeah, so that's what I did. Ran into the problem that I used all kinds of resources that were not available again. So I had to remove my process and add a task instead. But when everything was out of the way and the priority of my kernel module was also okay, the priority needed to be lower than the mounter library, because I called the mounter library to mount my partitions. Yeah, but then everything was fine. Suddenly I could load up this driver during boot. Yeah, so that is basically all there is to writing a device driver for OS4. Now, of course, this is not where it ends for my NVMe driver. I still have some features left for the future. Currently, my driver only supports 1 unit, and I want to support multiple units. Not that I expect that users might use multiple drives at this time. I cannot even fill my SATA drive, so my NVMe drives in my system are only there because I can. I don't use them actually, but I don't expect that users will use multiple NVMe drives at a time, but nevertheless, I will support multiple units. I also want to optimize the performance in the so-called area of interest, but what this area of interest is will be shown on the next slide when I show some performance figures. Something that I really want to do is implement deallocate, how it's called in NVMe, but well, everybody knows it as trim. This is a very important feature because flash-based memory works a little bit different compared to the old-fashioned platters. The old-fashioned platters do not need to erase data before you can write new data. And that is different for flash drives. Flash drives need to erase a location before you can write new data to this location. And as long as your flash drive is not fully written, that is not an issue, because your controller will simply write the new data to a new location and do the housekeeping. But as soon as your complete drive is full, your flash drive, your NVMe drive, will only know that it can erase a new location once it's been written. And an erase cycle takes a lot of time. So if you do not implement deallocate, your drive will slow down a lot. And also what I want to implement is something called true pipelining. Now you saw that I have one task that is sending a command and then waiting for it to complete. But it would be nice if I have a separate task for retiring IO commands so that you can get true pipelining where one task is filling up this submission queue and the other one is simply monitoring when the command is complete. This is interesting for when our kernel will support multiple CPUs. But for now it's not. Not really a pressing issue, and also the file systems are currently not multi-threaded, so it's down on my list, but still something that I want to do. Now let's see some performance figures. Maybe that is the most interesting slide of all. The blue bar represents my SATA drive. So the SATA drive is connected to the SATA ports of my X5000. The orange one is the Solie P44 Pro drive. That's an NVMe drive. But there's an issue with this drive because it fails to correctly enumerate in my system. So this was the drive that I was talking about earlier. This drive fails to enumerate to PCI Express 2.0. It is somehow stuck at 1.0. So the interface is in this case limited to 1 GB per second and not 2 GB per second. Fortunately, the Western Digital Black and the Samsung Evo do enumerate as expected. So these two drives have the full bandwidth available. But out of the three drives here, only the Samsung has embedded DDR memory. These two drives only make use of host memory buffer, so a piece of memory that is allocated in the X5000 DDR memory. Now in the previous slide, I was talking about the region of interest, and the region of interest is determined by our file systems. So these performance figures were acquired by my own little benchmark program, and my own little benchmark program is doing the same as SCSI speed, but SCSI speed has a bug that some timers overflow, so you get very low results. My benchmark doesn't have this, so it gives the actual performance figures. And what you can see is on the vertical axis, you have the transfer speed, so the actual transfer speed. and on the horizontal axis you have the transfer size. So the size of an I/O command that I send to my NVMe drive. And what you see is that the larger the transfer size, the better the performance. And this is especially the case for my Samsung drive, and not so much for the other drives. And that is also very nice, because what you can see is that the Samsung drive can reach 2 gigabytes, and that is also the maximum speed of my PCI Express interface. Now the downside is that our file systems, except for SFS2, but this file system has another limitation, do not use these kind of transfer sizes. They are limited to 120K transfer sizes. So when it comes down to real world speed, what we can use in our Amigas, then this is only the area of interest. And yeah, the drive can manage up to 2 times the speed compared to a SATA drive. And now you see that in this case, the cache-less drive is actually faster than the Samsung with embedded cache. So for our systems, cache don't mean a lot, but it is nowhere near its maximum potential. So when you transfer a large file, then a file system like NGFS will probably use 120K transfer sizes. And that means that we can transfer up to 600 megabytes per second with our Amigas. So 1/3 of the actual bandwidth. It is nice, but yeah, for me personally, a bit disappointing, because I would have hoped that the limitation would have been in my drive, but it is it's really in the file systems. Now, if you would use a benchmark program like disk speed, then yeah, all the drives perform similar, because disk speed is only benchmarking the cache of your system, so the DDR performance of your system, and not so much the actual speed of your drive that I can benchmark, or a SCSI speed should benchmark. Now, why is the speed low here? Well, partially, like I said, the file system, but on the other hand, especially at the very small transfer sizes, I need to create these PRP lists. And PRP lists are time consuming, and our processors are not that fast compared to a PC processor. So this is also a limitation that unfortunately is something that I cannot do very much about it. Yeah, that's it. I see that. Oh, it's already 22 past 11 local time, but nobody interfered. So I guess there was time left. So, any questions?
Yeah, Harold, thanks a lot for the presentation. I really like the detail. I feel your pain. I went through the whole Ethernet driver development in a very similar manner, having to take and figure everything out. But would your device code command line program, would the source for that be available at all?
Sorry, it's very difficult to hear you. It's like you're further away from the microphone.
Oh, I'm sorry. Might be having some problems on this end, I think. Yeah, no, I was just wondering if your the probe utility that you wrote for the command line for the shell to take and just do a probe of devices. I was curious if the source code for that, just that probe part would be available.
Well, currently is not. So
okay.
It's
just one of these examples that's missing from the whole picture. Just like the poor documentation in doing the device driver. It's these little techniques would be nice to be able to have small examples of how you do them.
The probe is actually not the hard part. The probe is just following the standard.
Yes.
And the standard has these chapters that give you the recipe how to write a driver. So first you do this, then you do this. So everything is there already in the standard. Really, like I said, it only took me 4 days, and it is very specific for NVMe because it only contains the NVMe part. The thing that would be interesting for device drivers, developers, is the Amiga part. And there I was hoping that, and it can be me, but hopefully it's someone else, that someone can create a framework and documentation about these basic needs that we developers need. So a framework of how to write a device driver. And that was why it took me nearly 3 months. It was not the NVMe part. That was basically 4 days.
Yes.
3 months to write a device driver, just because the information isn't there. I mean, afterwards, with all the knowledge that I gained from simply trying, failing, trying again, failing again, and to get something working, that took me 3 months. And if we want to progress our platform, that this basic information should be available as a framework and documentation, because the fact that I got it working doesn't mean that I did it the right way. And that is something that is bothering me. Because nobody can tell me what is the right way.
Hey, we got a question from the hotel here. LD, you want to hit it?
Let's try it. Okay, Harold, thank you very much. The presentation was just excellent, and there was quite a lot to digest. I would highly encourage at some point or another the release at minimum of slides. That's something that we can do. It's one of the best presentations I've seen on OS device driver in some time. But the other thing also is, I don't know if you've had a chance to talk with Jamie Kruger. He also ran into the documentation issue quite a bit when he was working on networking drivers. And it does seem like the people who have invested as much time as you two have kind of have to keep reinventing the wheel. I wonder if you would be interested in contacting him. I believe he was working on a set of skeletons, actually, a framework for people to use as documentation, source as documentation. Your experience would be very helpful in that effort.
Yeah, that is what I was trying to say. What we developers need, and I think what all developers need, is for each type of device driver. I mean, I just wrote an storage driver. Let's call it a SCSI device driver. But I can imagine that Jamie has some other experience in writing a network driver. There are probably other do and don'ts over there. And yeah, so it would really be helpful if someone who has the knowledge can write these kind of frameworks and also some documentations where the pitfalls are written down, like the do's and the don'ts. And this is something that is really missing at the moment in the SDK. And afterwards, if you look on the wiki page on amigaos.net, and if you look through the SDK, all the information available there, then if afterwards I can find the information, not all of it, but most of it. But yeah, it's not concentrated in one place, specific for these kind of drivers. And that would be very helpful. Now, am I the one to do it? I could do it, at least for a SCSI device. I can create a framework. But like I said, what I want to prevent is that and that is a bit, yeah, that's something personal, that an issue that I have with open source is open source is great, but it cannot be in substitution for documentation, in my opinion. So if someone creates something that contains the wrong way, then everybody will copy the wrong way of creating such a driver. And this is my opinion, for example, on I think it is pronounced ACI, so the audio system. There are ACI drivers, open source ACI drivers available, but in my opinion, they implemented in the wrong way. And maybe that is the reason why I can read a lot of complaints about the stability of certain drivers. So, I mean, we still have developers working on the kernel. So if someone can tell us what a driver should look like, it should be the kernel guys, because they are loading the drivers. So it would be very nice if the kernel guys, and I don't know who they are. I think Steven is one of them. I'm not sure if he's in the room with you.
He's hiding.
Hey, he's very quiet at the moment.
Yes, he is. Beyond that, he also has administrative rights on OS4's wiki. So that
Okay.
seems like that would be the place for you and Jamie, where you could add your, bits and pieces of code, the initialization, the kernel modifications, the kickstart kernel modifications and so on, and document them in the wiki. That's the central place to do it, the OS4 wiki. And
Yeah, well, maybe the best place is as an example in the SDK, but yeah, the wiki will do fine as well.
you can add commentary there as well as code segments, excerpts, and as little as I've done things, if I've tried to figure something out that wasn't in there, I added it on a few things that I've done. And we fortunately have the guy sitting here who can sign you up. So before that.
There's been
Yeah.
into the wiki.
So well, there is. Okay, anybody else?
So then I would be creating a framework for a SCSI driver as a non-software developer. Okay, that's interesting.
But at the very least, you can at least post your experience of writing a driver, and then we've got a guy here, coincidentally, the same one, who can review your code and comments and adjust them as needed. It's a wiki.
Yeah.
Imagine that.
I'm looking around the hotel here, and I believe you are the expert now. So congratulations.
Yeah. Then Amiga OS is really doomed if I'm the expert.
Hardware guy.
I'm an hardware guy. Yeah, maybe I didn't even properly introduce myself, but I'm actually a system architect. So for the last couple of years, I'm not. Well, it's not fully true, but I'm not actively designing hardware anymore. But as a system architect, you need to be specialist in one of the three areas. So I'm specialist in the electronic side. Well, now everybody can fasten and bolt, so that gives me also basic knowledge about mechanics. And yeah, software. Well, apparently I have some hidden talent for software as well. So yeah, that's my background. But yeah, mainly electronics. So I'm better suited to design a next PowerPC board than writing an OS4 application.
Here's true.
Oh, no, that's 10.
Any more questions?
Looks like we're done here at the hotel with questions. Anyone online have a question? If you do have a question, you're muted. All right,
Still people online.
all right. That looks like it. Well,
Oh, yeah.
thanks, Harold. That was quite a in-depth speech. We really liked it. I love the diagrams you put out there. I'm not a device driver, but I could actually kind of follow along. So great.
Yeah, I've never participated in a Devcon. I actually never watched the Devcon stream, so I didn't know what to expect. So maybe it was a bit too much. I don't know, but
Nope. We have some very in-depth conversations, and we have some very light conversations. It's all over the board, but yours was perfect.
okay. Well, My pleasure. I will create a PDF out of this presentation and then I will send it over to, I think, Stephen. Oh no, Bill, I also have your email, so I can send it over to you and maybe you want to post it online somewhere.
Ask him if he's gonna put his driver.
Yeah, so the question here was when, are you gonna repost your drivers to, OS4 Depot or?
You probably have inside knowledge. No, I made a decision to change the way I like to distribute my drivers, and it was mainly driven because I want to support the parties that still are willing to move our platform forwards. And if this sounds a bit cryptic, then, well, no, I don't think it is cryptic. I think you can already imagine how I'm going to distribute my drivers. So stay tuned. They will be available again, but not on OS4 Depot.
Okay.
All right.
If he wants one.
So, okay.
So he should set up a paid for site.
Don't worry, it's already.
All right. So are we ready to move on to the next topic? All right, Steve, I think that's you.
No, that's at 3 o'clock.
Is that-
Dan, you're at 3 o'clock?
I got 20 minutes.
Oh,
Well, so maybe you guys can answer this. When he does the pro, all those fields, are they a fixed offset from the base address? Like he does a transfer to those addresses, he pulls them back and it's on the spec, right? So all those fields are specified. Okay.
Yeah, that's just boring stuff.
It's not boring stuff because it helps you figure out things
No, I
like
mean, you
optimal buffer.
You get the bar and you're done. Take 2 seconds.
Well, I don't know how far past that base address to read unless I know the offsets.
Spec.
Yeah, that's what I'm saying.
Are you saying there's a spec?
There is.
There is.
Slide.
Yeah. There's like a 428 page spec. I read it while he was talking.
Yeah.
You did it? You didn't read it?
Yeah, we both read it.
How does,
It's 3 volumes. It's short.
and do you query the drive itself to determine information about the physical leak because it already knows that, or do you query the kernel to find out?
Kernel.
So you query the kernel, so they'll tell you what Gen PCIe you're running and what.
Well, it tells you where the bar is, and this bar is just 3 bytes.
Oh, that's it then.
It's so simple.
Okay.
There's nothing to it.
So you guys should probably read the documentation before I listen to it.
No, just go.
I'm curious.
No, all you'll get is a bunch of hex values and you got code with the spec.
That's fine.
Yes. And then you make it pretty straight like that.
Great.
You gotta do.
Yeah.
It's an unglamorous job. Well done.
All right. So I'm gonna mute my laptop and you can use the.
That one. There we go. Okay. You turn the speaker down. Thank
There
you.
you go.
Okay, okay. Takes a while to find the right button, I'll tell you. Whew. So I have no video on. Can I go next, or is Bill doing anything? Or is it just running itself now?
I don't think we'll do anything, just monitoring to make sure that. things
Okay.
stay now.
All right. What am I doing? What's the next? Oh, DMA, right?
Yes.
Okay. I have 4 presentations. You got to tell me what I'm doing next.
You got DMA and then Dan and.
I got your
That's
DMA.
it.
I got your DMA right here. I'll give you DMA. Okay.
We got the. So as long as we need it.
That's good, because we need it. Share screen. And I'll try to get it right this time. This one. Share. See, I'm getting better at this. I think I am.
I can see AmiWest, Devcon.
I got so many windows. This one. There we go. Am I at the beginning? Yes, yes. Hopefully everyone can see and hear. I assume. And we're all good, Robert? Yep, okay, okay. So yeah, I just wanted to do a quick overview. I'll try to keep it short and sweet on the DMA engines again. This is something Jamie went in depth with a DevCon tour ago, but work has continued on it, and I just wanted to review some of the results and where you can use it, because it's actually this close to available. So I'll get into that in a minute. So these are the general purpose DMA engines on the X5000 and A1222. So we're only talking those platforms. Other chips might have their own engines, but we're talking these ones. Now, they're implemented in the FSL DMA resource, which exists inside the SG kernel. And that was written by Jamie Kruger. He was contracted to implement this thing, and I put a link to his company in case you need a DMA engine or a driver or something. Give Jamie a call and make a deal, because he can write almost anything. He really helped us out here. So yeah, bit by bit software group. There you go. So there is a wiki page, and I gave a link to it, but this is not new information, because like I said, a couple DevCons ago, we went through this, but it's still there. X5000 and the 1222, they have 8 channels each, but we reserved 2 of the channels on the 1222 for the audio driver, because it turns out the audio chip on the 1222 is external to the SoC, the CPU. And so we needed a way to talk to it, and that's the way it likes to talk. It likes to talk through a DMA channel. So we had to take 2 away. But that's a normal thing you do on these kind of designs, so it's not a big deal. Now, the requirements, this is the tricky bit. So the weird thing is, it's in the SDK that you can download right now. There's an API there, and you can compile to it. But if you try to run it, it won't work, because the kernel isn't out in the public. Where's that Trevor character again? Anyway. So we are releasing the kernel because, of course, the 1222 is coming out, and that has new kernel. So the kernel's going out. It's just a matter of how and when. And I think I said that last year too. So I'm saying it again, one more time. But now we have an excuse that that can't be ignored. Like we have to release it. No more holding back, right? They need at least 5451. I anticipate we'll be releasing kernel 5460 something, I imagine, because this is a few releases back. And also I found out yesterday, that Jamie added more features to the DMA engine. So there's a couple new API functions that just came out fresh. Now, I don't have them in this particular presentation, but it'll be in the SDK as well. And I'm actually going to have to talk to the boys about getting the SDK released along with it. Hopefully we can do that coordinated, or I'll just throw it up on 404 Depot if we can't get it done quickly enough. We'll see how it works, because we need that out there, right? And it's just some header files and an autodoc, so it's not a big deal, and examples, right? So not a huge problem. So we played with, we've been playing with this DMA engine, trying to see what happens when we apply it to copy mem. So I don't know if you know a lot about Amiga OS, but there's a routine called copy mem. That's the heart of the OS that copies memory, copy from A to B, right? And the idea is that I should be able to get a speed increase if I use the DMA engine, right? That's the general idea. The old classic one, they even had the copy mem quick function. They were trying to make it quicker. And it never really worked that great, but it was there. And I can't remember, added some commands to the new ECC client. I'm not sure if we mentioned this before. It's the exec-sg command and control client. So this is a way to modify its behavior at runtime. So you can send commands to the kernel and it will modify behavior. And one of the commands is do DMA copies, turn it on, off, change the threshold to A or B. And so we had the beta testers and some developers poke at it and got some benchmarks, right? So I just wanted to show you quickly the results, because the thing that speaks volumes is results. Because we always thought, oh, it's going to be fantastic. Well, it is good. It is good. And these are the numbers I just had a few days ago. And you can see on the left-hand side, we have the size of the buffer or the copy that we're doing. And then the CPU means how many, I don't know, was it microseconds? Doesn't really matter what the unit of measure is, as long as it's the same on CPU and DMA, as long as it's the same unit of measure. And you got a number, right? And then I just did a percentage decrease on it. So it's that much faster, right? So you can see I got up 69% faster on that particular buffer size. And then you see some strangeness. It's like, oh, well, that's weird. It dropped at 512. Well, who knows, right? Maybe my test is wrong. Maybe the DMA engine did something funky. I don't know. But these are actual numbers of a running program, which I found interesting. So, you know, it's good. It's good. And then we look at it in a real world scenario, right? So one of the hopes was on a heavily loaded system where it's really, really busy, it should be able to offload the copies to the DMA engine and get back again, right? Well, that does work, but your DMA copies need to be about 1 meg or larger before you really notice it. So you have to have fairly large copies, right? Now this kind of goes back to what Harald just talked about. He said the file system was limiting his copies to 128K, right? Well, that's no good. We need to get his copies up to 1 meg or larger, and then we can use the DMA engine and really move stuff around quickly, because in Amiga, unfortunately, every time you want to edit or load a file or save a file, it's copied multiple times. So the faster we make our copies, the faster the thing will run. Now, other operating systems have evolved since, like Linux, where it does no copies. It tries to do 0 copies, right? Doesn't even get crazier speeds, but we have what we have, so we're going to try to speed up what we have. And obviously, we should have larger chunks of data moving around, because when we do benchmarks on the system, we find it's just zillions of small copies of 64K or less, just tons of them everywhere, all throughout the system. Sometimes you see like 3 bytes being copied. It's like, what, right? It's just terribly inefficient. So then the DMA copies have very little advantage, right? And on a general purpose point of view, like for general purpose, you're not getting a lot of bang for your buck, because it takes a lot of effort to set up your DMA copy. The engine runs like crazy fast, like super duper duper fast, comes back with your copy finished. And that costs money to set up and tear down, right? Not money, but it costs time, right? And so you got to offset one with the other. Now, one of the nicer features that Jamie added at the end there was chaining, where you can chain multiple different transactions into one big transaction, right? You take a bunch of little ones, chain them all up, and do one big transaction to the DMA hardware. And that's when you get a lot of bang too. So we got to be able to queue up these small things and make one copy out of it. Now, I also want to point out the SDK, as you can download right today. It has all these wonderful examples in it that show exactly how to use the API. And there's an example for everything. So it's very complete. We even got a stress test in there and a copy mem test. So it's a very feature complete, the examples. And I was just going to show them to you because I have them here. Why not? And then I just want to point out the current SDK, the one that's out in the public right now. You have basically two entry points: copy mem DMA and start DMA chain. The copy mem DMA is just your usual, just copy a block from A to B, with synchronous or asynchronous transactions though. So you can choose. That's a nice feature. Our current copy mem is blocking only in the OS. So and there's also this, like I was kind of alluding to, the start DMA chain, where you can chain multiple copies into one big mega transaction and just feed it to the engine and it comes back finished. Shows you how to use that. And again, synchronous or asynchronous, very feature complete.
But when you do it asynchronously, it sends a message to your fans.
Well, when I say asynchronous, is you call the function,
Yeah.
It returns immediately to your program, and then you can be notified in different methods.
Oh.
You can have a signal, you can have a notification function callback, right? So it depends on what you're doing, right? Yeah. And I do remember Jamie saying that the other two entry points, I think it was two that he added, are more for driver writers. So your heralds of the world, right? Perhaps. And they add even more ease of use, access to the DMA engines. So these engines are a part of the chip, and they're just like a peripheral in the chip that you can use, you don't have to use.
They can access what parts of the view.
They can access every bit of RAM in the main memory. Cards? That'd be a Jamie question. I don't think so. I don't.
Yes, they can.
Yeah, because that's going over the bus, right? That's going over the bus. Generally, chips don't do that generally, because that's a bus spec. Right, so-
Stephen? Can I ask you a question on this?
Question? Yeah.
All right, so one of the kind
I
of
burn it out.
I'm never entirely clear about is I've got some amount of storage that I want to move. Now, should I try to be smart and say that I know what the optimum sort of buffer size is and then break up each movement into an individual call? Should I use chain? How do I know? See, I don't know the performance of my memory subsystem. I don't know the internal workings of the DMA. I don't know any of this. I just know I've got some blob that I want to move. How do I know how to structure it? Do I just allocate a giant enormous buffer and say, go copy this to that destination? And it knows what to do. I mean, how do I set all this stuff up? How do I know whether to handle it manually or
So
make use of the chain feature?
I'll just reiterate the question a little bit, summarize it. So basically, the question was, how do you know how to set up your transactions, right?
Yeah.
Like, do I chop it up into bits? Do I make a buffer of this alignment? Do I do this size?
I know what this optimal size is.
What is the optimal size, et cetera, et cetera. And the only for sure answer I have is you have to test it.
Basically,
You have to test it to know for sure. Yeah, I mean, you do know for a fact, our current kernel, its favorite size is 4K. It loves 4K. And if you make anything 4K in a division of 4K, it likes you.
what's the default page size?
That's the default page size, yes.
21.
It loves 4K, right? But then there's layers on top of it, right? Layer after layer. And if you're doing disk driver, like Harald found out, the file system is your limiting factor sometimes, right? It has a certain buffer of a certain size, and it should also have alignment of a certain restriction built on top of the 4K pages, right? Well, what size is the best? And then to add even more complexity, you have like that, what was it, Sony drive? Throwing RAM in there too, to buffer everything.
Oh, with
Right?
caching.
It doesn't care what alignment and size it is now. It's chopping it up and right? So really, you can't know until you test, which is very frustrating for the generic programming types, right?
Or how much differences between the various architectures of the support.
Yeah, the various differences.
Supporting two now, but
Yeah.
the X1000 would be something else to support.
And that's for this particular DMA engine too. Like this DMA engine is one of the most flexible that I've seen in a long time. It can handle unaligned copies, and it can handle any size copy. Very unusual. Usually they're very restrictive. Like I must have it on this page. I must have it in this size. Yeah.
Let Jamie talk. Let's see here, let me turn the volume on.
Oh, does Jamie want to say something? Is that what you're saying?
That's the lab.
He says.
Whoops.
Echo.
Okay, okay, there he is. There's Jamie should talk now.
Can you hear me there? Hello?
I can hear you.
We,
Oh,
we,
okay.
we can hear you though, Toe. We just had some coordination issues on the PA. Go ahead.
All right. Well, I was just going to take and say I do have some data to take and answer some of those questions, and I did send some stuff to Stephen. I don't know if he had a chance to incorporate it, but I could share a screen here to show you some of the results of the testing. So I did a test series where I built a series of block sizes. So you have a number of blocks and a size of those blocks, and then copying it with the copymem, copying it with the copymem DMA single call approach, and then using the DMA chaining. And it really shows, you know, the kind of the optimal sizes and number of blocks and size of blocks really comes into the whole thing. So I can, like I said, I can show that if Stephen didn't get my PDF I sent him earlier, incorporated into this, and as well as the source code example of what it does. But anyway, continue. Thank you.
Show us the graph.
Can you share your screen and show us the graph?
Oh, sure. Let me see if I can bring it up here. Share the screen. Well, that's okay. That's sharing the entire screen. I just wanted to share the window, really. See if I can get it to do that. Okay, well, I'll just bring up the screen, share the screen here. This, and then go get this guy to go full. I have too many screens. Okay, hold on. So I got to do this first. I tried to simplify this by taking and turning off all of my external screens and just doing this on the laptop, but it's not making it a lot easier. Thought it would let me share just the window, but okay.
That looks good.
Oh, okay, can you see that?
Yep.
Now the
Yep.
question is, can I control it? Should be able to. Oh, there we go. Okay. Yeah, this is this is a block of data. Crap, come on. That's over there. All right. So what we've got here is we've got some numbers. Now, this is an example of the using setting up a series of 512 blocks of various sizes. So the first column here is, number of blocks. Well, it's all 512 for this test. And then the size of the bytes that you're doing per block. And then this is just the total size, 4K all the way through to like 128K. And then there's how long it took the DMA chaining to complete it, how long the copy mem DMA, and then how long for copy mem. And you can see the highlighted section here shows that when you hit about 512 bytes you're doing 512 blocks of 512 and larger, then the DMA chaining, it beats everything else. You can see it's 393 microseconds as compared to best case scenario with the copy mem, like 598. Now, what Stephen was saying, when the CPU is busy taking and doing other things, that copy mem figure gets a lot worse. But when you're doing the normal copy mem DMA, it's got so much overhead to manage taking and getting that single copy, especially when you are just giving it the virtual addresses. So it's got to figure out where it is in memory. It's got to figure out the scatter gather list of all the pieces of it, and then plug that into the hardware and then go. Where the DMA chaining, you've set it up ahead of time and you just tell it to go, right? So if you've got a whole chain of transactions of copies to do, you can kick them off, and then it doesn't matter really so much what the CPU overhead is, because it will take and not affect the DMA hardware as it just chugs through and does all of its stuff. So there's a graphical, there's the kind of chart view, kind of shows it. In this case, of course, we're looking at the smaller the bar, the better, the faster it is. And these results, let me see if I can show it on the other one too. I did a whole series of them. Let me stop sharing. Oh, wait a minute, I've got the screen now, I suppose. So where is it? Oh, right here. Got this control bar right in my way. There we go. Okay. Now, can you see that spreadsheet? Is it still coming through?
We're on the graph still, the bar graph.
You're still on the bar graph? Okay. Come on.
Know how to make drivers, you can't run clients.
I'm on the laptop using the pad and the mouse buttons, and it's like it's completely alien. I just don't do it.
The new wireless tank mouse does work on a PC.
I have them, yes, and they do.
Yeah. Yeah.
I've just got it's kind of a weird setup, because I have all of my I use like 6 screens all on the side of me here, so it's the laptop is set up and it's all tied together, driving everything, and I can't take and get my camera view and everything on the one side. So let's see if I can get the share screen to go again. Let's see if this works.
Yes, we see a spreadsheet with a lot of numbers.
Okay, good. So here, let's click it up over there. Come on. This thing is like my keyboard's not even responding. What the heck? No wonder I'm having so much trouble. Or it's this share thing. So there's I got to get this over so you can see the number of blocks. There we are. Okay. And so here you can see, and maybe hopefully I don't scroll this too fast. That first block of that's 8 blocks of, again, 8 through 256K of bytes, and it's the same kind of thing. Once it hits about 8K, well, then it's faster. And you go down, it's like, okay, we increased that to 16 blocks of transfer, and you're still looking at about 64. It's right about 64K. It becomes quicker. And then this one is kind of an anomaly. I don't know what causes it to gap like that, but when it did 32 blocks of different sizes, and it got like, well, 4K, did a 4K block in 97 microseconds, but then it did an 8K block, in 1511. So, and then it went right back down to doing 307. So I don't know if that's just an oddity or what, but the point is that it does take a lot of testing to kind of figure out where the sweet spot is for what you want to take and set up, but it's pretty consistent with the DMA chaining. Becomes the faster scenario whenever you're doing like 512 bytes or more, whereas the copy mem DMA versus straight copy mem is like what Stephen was saying. I mean, you may have to be pushing around a meg or faster to guarantee it's going to be quicker. And but to kind of address the question of, well, how do you know how to set it up? In the example of that demonstrates how to do this chaining function is a couple of routines that I wrote to show you exactly where to do it, and that is it's not that one. That's the debugger. See if I can bring that back up. And actually I have to go back out that far. Forgot what I was looking for. I just need this. There we go. Okay. There we go. Now my keyboard's working. All right. Can you see some code?
Yeah, we still see the spreadsheet.
Oh, you still see the spreadsheet. Okay. Yeah, well, in that case, let me stop the share again. And I will try this one.
There you go.
Okay, now we're getting there. All right, let me see if I can get some more space on here and maybe make this. I think that's about as big as I can get it to on here without going crazy. All right.
Good.
All right, so as long as you can take and read that, let me see if I can get down to, well, I should be able to jump down. Here we go. Yeah, see, I created a couple of functions called allocate DMA chain, initialize DMA chain, free DMA chain. I had actually considered the possibility of adding these to the API as externally available, but so far I've just done them as functions within the test program that's just distributed. So let's see if I can get back this time a little bit. Okay, so this whole test thing, yeah, it just takes and allocates 2 big areas of memory and then divides it up into these DMA chaining arrays. And the header file describes the maximum sizes and the optimum sizes. So like if you're doing a single transfer, an optimal size block size is about 64K. But it can do a lot more. So see here. Yeah. So what this function is taking and doing is it's literally just following the rules of the DMA hardware itself, and on how you set up this contiguous array, because that's what a DMA chain is. So you start with an array of repeated structures, and each one points to the source and destination of what you're going to copy, and then provides any parameters about how it's supposed to do it, and the size of it, of course. And then ultimately it'll end it with this this guy right here, FSL DMA end of line flag. End of link is actually what it is. So that's how you piece the whole thing together. So that's the best approach right now, is you literally just follow the example, use these functions, which will allow you to take in, allocate and set up the number of entries you want, and and you populate your pointers to where that's going to go, and then you just hand it to the hardware. Now there's another level to this as well, that not only can you take and set up a DMA chain and have it just execute the whole thing, but you can also set up lists of chains, and you can also take and tack on to the end of the list, even if it's executing right at the moment. So it'll just rip through it, and when it gets to the end, it'll go, oh, there's the pointer to the next one. So in a multitasking setup, you'd kick off a chain, and then your program would get control to take and set up the next one, and then you'd attach that to replacing the end flag thing, and just kick it off, and it'll go. So that's another step of improvement that can be made available, is not only giving you the ability to just start a chain, but to start a list of chains that you can dynamically add to. But the exact API for taking and doing that, I haven't figured out how much of it should be public and how much of it shouldn't be. Or, is it too much? I don't know. Those are kind of questions for Stephen, I think. But so, I mean, I just quickly, I just wanted to take and show that and to kind of answer that question. So let's stop the share here. There we go.
Thank you.
All that code you just said and showed is that's in the SD.
It is right now.
Yeah, good part of it. I'm still checking in the very last changes and stuff to it that I was doing over the weekend. I got kind of involved in the whole Devcon thing. Otherwise, I'd already have it done. But yeah, because I had to move it over, as Stephen knows. I had to take and pull it over into a previous pull of the kernel, an earlier build, before the latest experimental stuff, because the latest experimental stuff isn't stable yet. And so in order to fully test what I had done, I had to implement it into a slightly older kernel. And then I'm working on moving that stuff forward into the main one, and then committing the changes. But yeah, all of that stuff is going to be on in the SDK when they finally get it out there. And I'm also going to be working on expanding the wiki page with the functions that are missing from there and the examples that are there. So hopefully, if it takes a while to get into the SDK and the SDK to get out, you'd be able to see how to do it with the wiki page before that.
Yep, it will be on the test.
So
Thank you, Jamie.
yep, no problem. I'll let you continue.
And back to Steve.
There you go. I love that live interaction stuff. Now, hopefully Jamie's muted. Okay, so yeah, we're not crisscrossing each other. It gets really strange here if I talk at the same time the presenter talks. It's not fun in the live room. So there you go. There's that should help you out with your question.
Yep.
And I think Jamie alluded there that the DMA engine's like 64K. I forgot that.
Yeah, there's some sort of global leak it's set somewhere.
It likes that number.
Well,
Yeah.
he's actually got it set. There's a
Yeah.
SSL optimum
There's
something.
there's a define somewhere.
Yeah.
Yeah, there's a define somewhere. Yeah, in the header files. Yeah. Yeah. So if you want to use it for copying frames of a video or something around. I think we actually in the beta group, somebody did an Odyssey build that was using the engine as an experiment. If you remember way back.
No, I don't remember.
Oh, it was tried. I think Frederick tried it and wanted to see what it would do. It helped a little, but not a lot, right? It's again, we couldn't quite get the right balance there. Now it's there. Yeah. So you kind of have to have a scenario where you're moving data quite a bit in succession, like Jamie was saying. Like if you have a bunch of data, you're moving it all the time. Maybe an Ethernet driver kind of scenario where you got data coming in, going out all the time, and it just never stops. That might be the kind of application that it would apply to. Although the DMA the Ethernet driver has its own channels, so it doesn't need general engine. But you can imagine the kind of scenario. Yeah. It's really made to move data fast.
Yep, and then I think another net is don't think that you can get around the overhead costs, just use the chain. If you go
No,
large.
you're always going to have overhead with this stuff for setup. Teardown's very quick, but setup takes a while. Yeah. I think Harald had that problem too with his driver. He said setup time for those chains was quite intense. But once you set it up, it was like, wow, yeah. So same kind of scenario again. The hardware is fast, but you got to set it up correctly. Yeah. So there you go. Any other questions? Because we're late on our other presentation here. Little bit, 15 minutes, not too bad. Any burning questions from the internet there?
I see nothing.
No? All right. Then I will hand it over to the next guy.
Okay, do we need to do some setup here?
Yeah, I think he
For the laptop.
Or have you?
asked the boss there.
So just for the folks online, just so you know, we're gonna probably do a little bit of switching, get the right equipment set up. See if we can't get the next presenter onto the Zoom stream, and then we'll get going. So probably need 5-10 minutes of setup. Good time for a bio break if you need one. All right, hello everybody online. We're back at the hotel. We've got our AV worked out. Taking over next will be Dan. He's a video game developer, had a concept that would lend itself well to the Amiga. So he is getting into Amiga development. So Dan, take it away.
Hello, everybody. So I guess it's time to go back in time because we're doing 68K now, classic Amiga. So I'm gonna go ahead and just start with a gameplay demo that I came out with last year. So if you saw it already, I apologize. But if this is your first time seeing it, then I hope you're in for a treat. And then I'll get into everything I have going on, the dev environment, and how I put together the game. And all that. So yeah, let's just get started. Oh yeah, one more thing. This is a tech demo. The gameplay is going to look very, very, very hard. It will not be this hard when I actually release the game. So that's a preemptive warning. This is just internal. I'm the only one who can play this right now. Just want to, if you're here, you can try later. I have an Amiga 500 that it's running on, so feel free to give it a try, but you're not going to have a good time, trust me. All right.
Sounds like a challenge.
Okay, we'll see. We'll see.
Sounds like a throwdown.
All right. I'm gonna pause real quick. Oh my God, sorry about that. I'm gonna skip most of the dialogue, just because it goes on for a little bit, but there's some narrative content in this game as well. There's, you know, a story about your main character and the journey that they go on and some of the people they meet along the way. But for the sake of expediting things here, I'll just skip most of the dialogue. That's the end of the demo. And there's some echo. So I hope you enjoyed it. Looks like I took 4 hits. Oh, thank you. Thank you. I really appreciate it. So I've been working off and on for 2 years on this. You know, it's kind of a side project. And as I'll talk about later, this will probably be released not just on classic Amiga, but on Steam and all of that. Really trying to make it look, feel, and play like a modern indie game. And I hope that comes through in what you've seen so far. So let's go ahead and switch over to the presentation. No, I don't want to leave the meeting. What the heck? Okay. And yeah, we'll jump into the actual talk. And
That's assembly?
it's assembly. Yep.
Oh,
68K assembly.
Wow. You are freak.
Yeah.
So this is new language. I don't know if you've heard of it. It's called C.
That's so
I
new.
don't know. That might be a little new for me. I say that I'm the youngest one in this room.
It's not as impressive as you think.
No.
We're pretty old.
Yeah, that's true. Yeah, and if I didn't mention, this is all stock A500, so 68,000 OCS. Yeah. Okay, so some of the stuff that we're going to go over today is general inspiration and scope. So, you know,
Are you on mute?
no, I'm not muted.
Okay, must be picking up on my system. All right, you're
Okay,
good.
as long as everyone else can hear me. Oh, I can
Think
change
just
the
because
chat
we're
here
close,
as well.
our machines are closer than what Steve and I are. So,
Okay.
so you're good.
Okay, just all right. Yeah, so I'm a game developer by profession, so I can, you know, give you a peek into kind of my world a little bit and what goes into the game design process, how I come up with these ideas. You know, beyond just the programming, there's a lot of game design considerations to make as well. So we're gonna talk about that a little bit.
You do that professionally?
Yeah.
And you just do this as a hobby?
Yeah. So, but thank you. It creates a very interesting intersection between the two worlds, which is why I mentioned it'll be on Steam and all that. It's, you know, part of my job as well. So, okay. And of course, I'm going to show you my dev environment and some of the build tools that I put together in order to make this possible. Going to show as part of that, you know, the data files, like how I put the levels together and compile them in a convenient way. And basically how easy like modern tools make that with a really rapid iteration process that allow us to design very quickly. Of course, I'll go into how the game engine works on a bit more of a technical level. Things like, you know, the way the bit planes are structured and drawing the bobs and the sprites and how I'm using the color palettes, various performance tricks and the physics and spawning in of objects and all of that. And then my plans for release as well. And then I'll give you a sneak peek of some of the characters that we're working on. Okay, so a little bit about me. My name is Dan Salvato. I am a lifelong Amiga fanboy, as I mentioned, game developer by profession. I'm 31 years old, which I guess kind of just caught the tail end of, you know, of the Commodore legacy, you could say.
And is that how you got interested in it?
Yeah, lifelong Amiga. Yeah, my family had an Amiga growing up. So, which is kind of funny because I wasn't even sentient when Commodore went bankrupt. I was still, yeah. I mean, I don't know. Maybe, yeah.
Neither was Commodore.
Yeah, true. I mean, I don't know. Maybe the joke's on them because when they were shitting the bed, I was the one wearing a diaper. So. Okay, so back around 2012, I dove into assembly for the first time by modding GameCube and Wii games. I was a big part of the competitive Super Smash Brothers community. And so I was making mods for those. So I was diving in. There was, you know, an excellent emulator, the Dolphin emulator for GameCube and Wii that had incredible debugging tools built in. So it was pretty easy for me to just look at the disassembly and poke around with it and mess with it. And that's how I got into it. And it's not all too different from 68K assembly. I mean, it was kind of the successor in spirit. So a lot of the user friendliness and elegance of actually working with the assembly is carried over. So it felt like a natural fit going back to 68K. But anyway, as for my actual start of a career as a game developer, so in 2017, I released a game called Doki Doki Literature Club. It's a psychological horror game, and it got very popular unexpectedly. It became the #1 psychological horror game on Steam, and I think right now it's sitting at about 12 million downloads. It's a free game, so no, I'm not loaded, just putting that out there as well. But I don't know if you
A quick plug, Eric Nelson comes to AmiWest sometimes, Cody less so, the Pixel Guide podcast. And they went through a period of time, about 6 months, where all they talked about, well, not all they talked about, but continuously they would come up with Doki Doki Literature Club and some reference into something that they were doing.
Really?
So it was
That's amazing.
phenomenally popular for a while.
Yeah, that's really amazing. I missed that, unfortunately, but maybe I should check some of their content out. But yeah, I mean, if you have kids who play video games, just feel free to text them and ask them if they heard of Doki Doki, and if they say yes, I brought some buttons and keychains that I'd be happy to hand over to you. Awesome. All right. Amazing. All right. Yeah, so since then, you know, I guess I call myself a professional game developer now, even though I just like made this one anime dating sim in Python. But I have a few new projects in the works. This is the one that I'm kind of public about again because it's more of a passion project. So you know, I just show off some footage and release details surrounding the development and all of that, and that's why I'm here as well. My other projects are secret still, but they're not Amiga games, so I can say that. Yeah, and then my handle's on screen and my personal website that has a blog which goes into some more detail about the game as well. You can find me on, you know, that same handle on a lot of platforms: YouTube, Twitch, Twitter, Mastodon, whatever. Okay, so I want to talk a little bit about the inspiration for this game, again from a game designer perspective. The first thing is that Amiga never stopped being cool, which we all know, of course, which is why we're still here. It's been, I think I can confidently say it's been a lifelong dream of mine to make an Amiga game. As I got older, the system only got cooler because I started to understand the incredible technical capacity of even the original Amiga relative to its time. And then starting to learn about things like the bit planes and the blitter and the audio chip and all of that, it just continued to fascinate me, and I've always wanted to make something for this system. But the thing is, I had to ask myself, well, what's something really cool that we can do with this hardware? Something that doesn't just try to imitate like your typical chunky graphics. You know, the bit plane graphics and the blitter are so interesting. I feel like if I can come up with a concept that leverages those in a really unique way, then I can, I don't know, really kind of push the system to its limits and do impressive stuff in a gameplay environment, rather than do something that is the same as everything else out there, but just a little bit more low fidelity. So I was thinking a while about that, and one day I thought bullet hell. I was watching. There's this sort of subgenre of bullet hell games I watch, you know, not your shoot 'em ups, like just honest to God bullet hell, like blanket the screen with bullets. And it got me thinking, like, so if you just blitting on one bit plane, how fast can you actually do that? Can you blit fast enough on a single bit plane to you know, to actually draw that many objects every single frame and maintain a full frame rate of 50 or 60 hertz? And yeah, and it turns out that you can. So I ran some like initial benchmarks, and this was my first foray into Amiga assembly specifically. But starting off, this was my first program. It was called Test Balls, and I just wanted to see how many of these, you know, these bouncy balls I can draw on one bit plane, And yeah, it turned out to be a substantial amount, even though I was brand new and I was probably writing some unoptimized software. Maybe 100, over 100, 150 to 200 maybe just bouncing around the screen.
How much code went into movement in each ball? And in your game, there's a lot of geometry. It looked like patterns going on.
Yep.
This seems a little more random, but how much CPU do you have left?
So
To still guide the balls.
So for this, I mean, it was more like, how many balls can I spawn before I run out of CPU?
Yeah.
And this was it. And yeah, this is very simple. It's just like each ball just has a position and a velocity. You add the velocity to the position, and that's pretty much all you have to do. Yeah, and then you have to blit it, of course. But yeah, that's what I managed to do. And then later on, my project became known internally as Amiga Bullet, and this was a new benchmark that I did, where we have not only a more interesting pattern, they have gravity now, but we also have particles running in the background simultaneously, along with some nicer graphics. And by the way, this background was just like a free asset that I found online that I imported into the game. It's like a placeholder asset. We're still working on the final graphics for the game. Yeah, and then finally, where we are now is the title of the game, which you heard, Magicore Anomala, as it's finally known as. I was inspired by, there's a lot of Japanese gaming and anime influence in this game. They really like to kind of mash together English words, like nonsense English words, and they think it sounds really cool. So I was sort of inspired by that. You have, I don't know, these other games like Blaze Blue Chrono Phantasma, and like just just stuff like, yeah, it doesn't matter. It sounds cool, right? So that was sort of the inspiration for the title. Okay. So I had to think a lot about scope for this game. I had to think a lot about scope for this game because I have to release it eventually, of course. It's already been 2 years and it's still kind of vaporware. So, but part of my job or expertise as a game developer is understanding the scope of a project. When I plan it out initially, it's like, is this feasible for me to actually do in a reasonable amount of time? And that's something really important that I think a lot of aspiring developers, when they ask me about what I think about their ideas and things like that, it's something where it's really hard for them to get the scope right. Something that is achievable within your own set of skills and the amount of time and budget and energy that you have.
And with those skills, did you do the music and the animation as well as everything?
Just about, yeah. I did the music, the coding, of course, and the character sprites. I did those, but at this point, I'm starting to bring in more people to help out. So musicians and artists to help with the final assets.
So it's your skill sets. It's really multiple skill sets.
Yeah.
It isn't just you planning it, it's actually you doing it.
Yeah, game development is unbelievably multifaceted. Which on the one hand, if you're doing it all on your own, it can be really tough because you can be an amazing coder, but if you can't do graphics, then you're kind of stuck. But on the other hand, if you only have one skill, then no matter what kind of skill it is, it's probably going to be applicable to game dev in some way. So if you do find people who are looking for various talents to work on a game, then you'll be able to lend your skills to that, which is really amazing. So as I mentioned, this is what I consider a modern indie game. I want it to look, feel, and play like a modern indie game. But that's a pretty high bar, We're still running on a 7 megahertz CPU. So that plus the amount of time it takes to code an assembly means that I have to keep the scope in check. That is, so it's pretty challenging. Like, how do I put a game out on Steam with these limitations that doesn't really show and makes people today not like the game, even if they don't know it's an Amiga game? That's a challenge that I'm going to have to face. But I think that I need the game to have high replay value. So getting the most out of limited content is really important. If it's going to be, let's say you get good at the game and it takes just a few hours to play start to finish. It should be, this type of gameplay should be fun enough that you want to revisit and play it over and over. Maybe there's different paths you can take or different abilities that your character can equip, so you can try playing the game in different ways every time and see what you like the most, or try to challenge yourself and take the hard route. or try to beat it as fast as possible. Try speedrunning the game. That's something that I'm really into as well, and I'm thinking about. Another part of scope is to really just, when coming with these concepts, you want to focus on one thing and do that one thing really well. It's like, I don't think your game concept needs to be propped up by this whole host of like this whole mountain of ideas in order to turn it into its complete into a complete game. You know, we're kind of spoiled by AAA games in that way, where there's just especially like the past 5-10 years, like these open world games that just, you can literally never run out of content. You could play for hundreds of hours and there's still more to do in these games. But my philosophy is just pick like a core game mechanic or game concept and just do it very, very well. Kind of hone in on it, focus it, and make sure that's really, really fun. And then maybe over time you can slowly add additional features to the game. And as a part of that, this game doesn't have scrolling. I don't think it needs scrolling. So during these battles, there's not really much point in having a scrolling screen. And then for other methods of traversal, you can just have the system where you reach the edge of the screen and then maybe it scrolls over to the next screen. That helps a lot with keeping certain parts of the game engine simple. It conserves RAM, makes the game logic simpler. I also want to make sure that I'm only using the blitter for the attacks layer, the bullets themselves, and not trying to blit these complicated graphics like as part of the background or other complicated game objects. So I'm either blitting the attacks layer or everything else can just be sprites, like the characters, for example. And we want to utilize hardware collision. It would be, you simply cannot do manual collision tests for this many objects on the screen every single frame. That's not feasible. So we want to, but this goes hand in hand with the design of the game. We need to design the game and the engine in such a way that we can leverage hardware collision as well. So these were some of the considerations that I had when conceptualizing this game. Touching a little bit on modern game dev versus retro game dev, this comes up quite a bit for me as well. You know, people ask like kind of what it's like to develop games for these old systems as opposed to more modern game engines, and what's the trade-offs, and you know, why would you want to suffer doing this in the first place? And yeah, it's true. Designing for retro typically means that 90% of your effort is going into the engine, the stuff that people's not actually going to see, and then maybe 10% of it is actual game design. But that can be fun, you know, if you like that sort of challenge, then it's, you know, and that sort of problem solving can be really fun to work on. And of course there are existing engines out there. I mean, Amiga has plenty of them, right? There's Amos, there's Blitz Basic, and there's some newer ones as well. But they might be designed for certain types of games. They could be limited in their capabilities. And so if you want to do something extremely novel, like I have going in this game, then maybe you just need to do it from scratch. But you can take either approach. And typically for other retro systems as well, there are these existing engines that people are making that you can make certain types of games in, whether it's like simple platformers or RPGs. Yeah, there's just many more tiny problems to solve when you're developing for a retro system like this. It's not really high level problems anymore. It's just like the basic, like coming up with a data structure for every single thing, and every little function is kind of its own problem that needs solving. But there's a plus for game development. It can be great to target kind of niche, passionate communities. You know, a lot of people are making indie games and throwing them out on Steam and kind of just hoping they catch on with their limited marketing budget. But it turns out that there are communities like this one who just are all over any piece of software that's being put out. And there's a lot of enthusiasm and a lot of passion. And if you share that passion, then you really have the opportunity to get a lot of exposure by providing something great to these niche communities. So I consider that a huge plus for developing games like this. Okay, I'm going to spend some time showing off my dev environment. Let's see, this is going to be pretty loosely structured. Let's see, do I need to exit? Oh no, I think I can just Alt-Tab out. There we go. I am using Vim or NeoVim to develop this game. Does this need to be? Yeah. Let me zoom in a little bit. Is that all right?
Yeah.
Okay. And okay. So if I'm going to be honest, VS Code is probably the way to go. I just, Vim is, it's fun for me to use, and amazingly, there are a couple plugins that for Amiga assembly development that are available on Vim as well. But I have VS Code up here as well, and again, I probably just not that big. Okay, and VS Code, there's an amazing extension for VS Code that's just called Amiga Assembly. You grab the extension, it basically sets up the whole build environment for you. It grabs the binaries that you need, like the assembler binaries. It grabs the emulator, not just the emulator, but a special fork of the emulator that includes the debug adapter protocol, so you can do your debugging right in VS Code, which is incredible. Breakpoints and step through your code and watch memory and stuff like that. They've made it unbelievably accessible. So yeah, I was on VS Code for a while, and it honestly works great. I just switched over to Vim just for fun because it's my own personal preference. But this is pretty much how I do things. I mean, I have just a hotkey that runs a quick build script if I want to run a build. Let me see. I think I can just do that right now. Yeah, and it pops up in less than a second. So the iteration is just incredibly fast. I can make a change in code and it builds in just less than a second. And here's an attack I was working on. It looks kind of like a bird flapping its wings. And then if I want to, I just have kind of like a temporary function here that's, that loads in the game scene in the attack that I want it to load. So I can, change the attack number, jump back in and test out this other attack. Yeah, the iteration process is just really, really fast. Here's another one I was working on. This is, I'm gonna have a level that takes place kind of like in a library. So the boss here is gonna have sort of these like brushstroke and Japanese character themed attacks. So that's one that I was working on. And then let's see. So let's not use the attack. Let's take out the enemy, and then let's instead load some of the rooms. This is a more recent feature as well. I started working on having kind of a set of rooms that's like an obstacle course that you traverse before you reach the boss. And right now, of course, it's very ugly. It's just placeholder graphics. It looks kind of like a ZX Spectrum game with the kind of the 1-bit graphics there. But it'll look a lot nicer once we actually have graphics done. So yeah, I can test these out, and I'll show you in a second how I build these rooms and get them into the game. But yeah, we can go over here, and then it takes you to the next room. Again, no scrolling, keeping the scope in check. Yeah.
What do you have the blue line showing?
Oh, so that's just, yeah, that's just a visual effect for when you do an aerial jump.
Okay, so it's not helping with you to positioning or testing or anything.
No, that's an actual visual effect for the game. And then you'll notice when I use my third aerial jump, 1, 2, 3, it blinks to tell you that it's your last jump. Maybe it doesn't really show up on Zoom because the frame rate isn't high enough, but whatever. Yeah, so this is it's pretty much my environment, and some of the convenience features are you can highlight any assembly instruction and look at the documentation for it just right in here. Oh, and VS Code can do all of this too, by the way. So this can be incredibly useful if you need to see, for example, which condition flags are being set by the instruction. And then it is the same for, let me see if I can find an example. So this is, yeah, there's an Amiga assembly extension for Vim that provides this feature. Or it's an Amiga assembly language server, and NeoVim has supports the language server protocol, which is the same as VS Code on how you get language support built in. And so it's kind of like an API where you can, there is for example, kind of a documentation API that they can that they can interface with in order to provide these sorts of features.
Exact same help text, whether or not you're in Vim or Visual Studio.
Correct. So I can do the same thing, mouse over here, and it looks a little bit nicer because they have Markdown, but yeah, it's the exact same. And then
Looks nicer, but it's not.
It's compact.
Vim, it's compact. You can like see most of everything you need right in that one screen.
that's true. That's true. Although to be fair, I have not really done much customization with the VS Code on the visual side. I mean, it has a ton of customization if you really look into it. It's just what they give you on the tin is not what you have to stick with. But I never really looked into it. And then aside from just instructions, comments that you write. So this is one that I wrote, for instance, for this macro. It provides those as well, which is, again, this is stuff that you typically expect for an IDE, but you're used to having it in like higher level languages like C. But you know, the fact that they put effort into providing this for Amiga assembly is amazing. And then I think I can, yeah, and I could just jump to the definition of the macro like that. And here's my comments. It's incredibly streamlined and useful. It's these modern tools. If it weren't for these tools, I don't think I ever would have gotten into this, because it's just the whole dev process is so streamlined. You have rapid iteration. It's you know, they've done away with so much of the stuff that, like, when you're just getting started, you would just bash your head over, spending hours trying to set this stuff up. And that's been really amazing. So let's see, getting into the build tools a little bit. So I was showing you some of those rooms earlier that I was traversing through. And I mentioned I was going to talk about how I get these into the game. And again, I'm pretty much using all modern tools for this. You have to figure out, like, you know, I'm creating the graphics, creating the room layout, and I need some kind of pipeline to pack them into some sort of binary format and then give them to my game. And then my game understands the data structures and then goes and draws them to the screen. It's a very multi-step process, but again, modern tools just make this process so streamlined. So much, in fact, that I'm gonna jump into Photoshop here. I just have an image of the room, and I can just draw and like make modifications. So I can like, let me see, I'll just, you know, put this up here, and I don't know, maybe this part's too hard, so I'll get rid of, oh, not like that. I need to draw black over that. Yeah, get rid of that obstacle. And then I'm just gonna save this file, jump back over here, build again, and that's it. That's my room modification. So now when I go in, you'll see the modified room. It's unbelievably fast to perform this iteration. It's incredible what modern tools provide us in being able to do this. And as part of this, I created an open source piece of software written in Python. It's called Simple Binary Builder. You can find it on GitHub. But what it allows you to do, and this is not Amiga specific, this is general purpose. So anytime you want to create just custom data structures and pack them into a binary format, it's an extremely simple way of doing it. So I'll show you an example. Let me bring up this file. So it uses TOML files where you can just, you just provide integers and strings for whatever pieces of data that you want, and then you can, in Python code, and even if you don't really know Python, I made it simple enough that you should just be able to do this. So I created a data structure that I call room, and then using type annotations, every single component of this data structure, I name it and then specify the type. So there's Booleans, a U16, a couple of arrays, and right in my code, it's like a self-documenting piece of code that shows me the data structure for this object. So this is the room that we were looking at, and you can, you know, see there's like a starting position. There's something that specifies the exits, and then the hazards image that I was messing with in Photoshop just a moment ago. So yeah, using my tool Simple Binary Builder, you can just very quickly put together these data structures, feed it a TOML file, which, let me see, there should be sprite sheets. Oh, this is common. I have to open up.
Was it TOML file?
A TOML, it's just a type of markup language. So you have like, you have like YAML, for instance. So TOML, it's designed to be a very human readable markup language. So instead of JSON, or in some cases YAML, I mean, YAML is very nice too, but it's designed to be very flat. So instead of having like nesting and all these brackets and things that are good for computers to parse, this is designed to be very human readable and human modifiable. And for that reason, I chose it, but also because it is, Python has a library built in to parse TOML, and so I didn't need to bring in an external source. So let's see. Yeah, so down here are some rooms that I'm specifying. Again, I just have what you saw in the data structure, has hazards, has tiles, starting position, the exits, and all of that. Then back here, it matches the same data structure. Yeah, so as part of this pipeline, as part of my Python script, it takes the PNG image, which is, it's not an RGB PNG, it's an index PNG. And so I just have something in Python, which is really, really good at parsing images, to just look at the pixels. And in order to figure out where the platforms are, it looks at certain pixels and sees if they're like color index 1, for example, which means that it's a platform. And then it looks for pixels that are color index 2, which might be the hazards layer. And then in Python, I am calling a subprocess to another program that converts PNGs into Amiga bitplane format. And that's another reason Python is so incredibly convenient for this, because you just, it's such an easy toolkit to use. It has, it has like everything in the kitchen sink or whatever, everything but the kitchen sink. I don't know what the actual phrase is, because there was the kitchen sink for the Amiga video toaster, and they kind of have the marketing like, okay, whatever.
It's been a while.
Yeah. Yeah, but Python is so convenient for that reason. It's like, it has a library just for everything. So for image processing and for calling subprocesses, it's extremely easy. So yeah, things like images and sound effects, I could just bring in as PNGs and use the right tools to convert them into a format that Amiga understands. Yes, so that's a little bit of a peek into my build process. And I even have a scripting system for writing dialogue. Let me see. So this is some dialogue that you haven't seen yet. It wasn't in the demo. This is for the library scenario that I was writing. And by the way, it has syntax highlighting, because it is really, really easy to add custom syntax highlighting in Vim. It took me like maybe less than an hour, so that's very pleasant as well. Yeah, and then
Now you can only write dialogue. Because that's another one of those specialties.
yeah, writing as well. You're right. That's true. Yeah, so I just have what was the file called? Dialogue.py. That sounds correct. Yeah, so this is just a big Python file, again, that takes this script format and looks at the opcodes like label, clear, char, and then numbers to choose like the portrait, jump, things like that, and converts them into different byte opcodes. And using, again, simple binary builder, it packs them into a binary, I send them over to Amiga, and then on this side I have the same thing, all the opcodes for all the different dialogue commands. So very easy interop between both systems, and it's incredibly pleasant to use something as flexible as Python to do all of this heavy lifting and keep it in sync with the data structures on the Amiga side. So let me make sure. I want to keep an eye on the chat as well in case people have questions or comments. But yeah, I mean, as for like this environment of build tools, if anyone has questions or like wants to look at anything in particular, then I'd be happy to show it off.
So when you go to create a build, you're running all these Python scripts as part of that build
Correct.
process.
Yeah.
So this isn't necessarily just the out of the box build you would get from this whole extension. You had to insert your build steps into the out of the box build process.
Sure, but it was incredibly easy. I mean, I just have this shell script that all it does is run the Python scripts and then run the VASM builder, and that's it. Like there wasn't really much intermediary work at all. It was just a very simple shell script to first run the Python scripts and then run VASM. So that was really straightforward as well. And I have almost no experience. Again, I don't have experience with C, amazingly. I'm doing an assembly, but never really touched C. And so one of the great skills you get in knowing C is the build system, because it is not really easy. You know, make files and linkers and all of that. I'm pretty new to all of that, but again, this was simple enough that I was able to make it work without much friction.
So the Python to like do the scripting, is that putting out assembly code that then gets compiled, or is that putting out a data set that gets read in by your program?
Yeah, the Python puts out data.
Okay, so that's just
Yeah.
data set.
So yeah, so again, like data structures like this, where you just have, and then on the assembly side, exact same data structure. So bytes for has spikes, has tiles, event ID, etc., and they're perfectly in sync. And if I wanted, I could, like, you know, just on the fly, if I want to change this data structure, which you're doing a lot when you're, you know, iteratively developing these games, you're like, oh, I actually need this piece of data in there. It's like if you come up with a small new feature on the fly, you realize you're missing something. I can like add, I don't know, magic number after event ID, and then create a definition to set the magic number. And then I can either pull this from the TOML file that I was showing you before, and it's smart enough to pick it up automatically. It sees that it's called magic number and it'll bring it in. Or I can write a function in Python to like set it myself. So I can just do that, for example. And then, why is it giving me an error here? Oh, look at that, because I already wrote it before when I was testing for this presentation. There it is. There it is. Man, I seem less smart now because this was all planned. You walked right into my planned presentation. So anyway, yeah, so I inserted magic number here, and now let's go back over to here, and let's see, it was after event ID, right? So if I do this, and we, well, actually, let's see what happens if I don't include this. We expect it to crash, obviously, because now there's a misalignment between the data structure of the binary and then the one that my program is expecting. So let's run this and see what happens. Just for fun. Oh, goodness. Okay, so now I'm all the way over here and the tiles are messed up. Okay, yeah, but that's expected. So let's put this in here and see if that fixes things. Yeah, there we go. Okay. And this is something I was stressing over for so long, was how to, like, you know, working with these sorts of data structures and how to kind of build my level files and take data from outside the game, you know, the game design stuff, and actually put it in the game. And that's why I came up with this system to make it very seamless and have it be part of this rapid iterative process, kind of like everything else is in developing this game. And that's part of, again, the 90% engine, 10% game design. Well, a lot of the engine stuff is done. So now when I go to design the game, I can actually make a good game because I can test ideas very rapidly like that. So, okay, let's head back to the presentation now. And also, how are we doing on time?
Don't worry about it.
All right. Oh yeah, it's the last presentation, so I get to keep you here as long as I want. But you know, if you want to get up at any point, I won't be too offended. It's not like I flew out here or anything just for you. So,
where'd you fly from?
I flew from Boise.
From where?
From Boise. Really not that far. So yeah, don't worry about it.
There's Amigas in Idaho?
There, in one house there is. But at this point, I probably have enough for the whole state. I have like 2 closets full of them. So, okay.
While you're here, pick up some more.
Oh, I would love to, as long as I can get it on the plane. I don't know about that. How they would feel about maybe lugging like a couple of CRTs under my arms with me onto the flight. We'll see.
Carry on to me.
Yeah.
So 10, 3.5-inch floppy disk drives last year back home. TSA was really.
Okay. I don't know. I mean, I stuffed an Amiga 500 into my carry-on bag and it went right through. So that was pretty impressive.
The last couple of years, they're much better about computers.
Yeah.
5 years ago, they'd make you take it out and sniffing it. What is this strange box? You got it in your computer, working on it.
Okay, let's talk about bit planes. Something that might elude the knowledge base of people doing Amiga OS 4. Well, then again, I don't know anything about PowerPC Amigas. For all I know, maybe they are using bit planes for some godforsaken reason, but I hope not. Okay, yeah, as it should.
We all came from CCK.
Yeah, okay. So I mean, is everyone like mostly comfortable with bit planes? You can raise your hand if you're just like, you never fully understood what bit planes, how, you know. Okay, yeah. I have sort of half an explanation. I didn't want to, start from zero, but I'll talk a little bit about how the game is structured anyway. So the background is 3-bit planes, so it's 8 color backgrounds. Of course, you can, as you know, you can use the copper to just change the palette at any horizontal line. So if I really wanted, I could, if I wanted to get more 8 colors, like you have maybe the sky area on the horizon and then the ground, I can sort of get more than 8 colors out of the background. But for the time being, the backgrounds are just 8 colors. So 3-bit planes for that. And then the attack layer is on bit plane number 4. So this gets laid over on top, and with my handy graphic of the red ones, you can see that once you add the attack layer, wherever a pixel is turned on in the attack layer, you go from colors 0 to 7 to colors 8 to 15. So this is the 4th bit plane, and there are technically 8 colors assigned to the attack layer, but you don't actually get to use all 8 of those colors because they're dependent on the background underneath of it as well. So
Unless you want to hide a pixel.
yeah. But I mean, in the context of my game engine, the background is static, and I'm only blitting to the attack layer. So I'm not trying to do anything crazy and fancy. But yeah, I try to do something like this, where since the the pixel of the attack layer is dependent on the background behind it, I try to take the background color palette and sort of transform those colors, shift them up, or shift the hue a little bit in order to create this interesting kind of additive blending effect.
Sort of transparency to it.
Yeah, and I think that looks very cool. And there's all kinds of, just by changing the color palette on the fly as you play, you can do all kinds of interesting and cool color effects, which so far in the demo, I haven't messed with all that much, but kind of the infrastructure is there in order to mess with the colors, which we're going to talk about right now. Look at that. I planned it very well. My segues.
The next thing, real breakthrough was that you could use colors to animate.
Yes. Oh, yeah. The palette switching to create pseudo animations. That was popular in video games, even kind of just like waterfalls kind of falling. They just switch the colors. Yeah. Oh, and even the Boing Ball did that, actually. It was just slices of different colors and they shifted the palette. Okay, so as I mentioned, background is color 0 to 7, attack layer is colors 8 to 15, but we don't really get to use all 8 of those colors. Color 16 is transparency for the sprites. Colors 17 to 22 are for the player sprite. So the player sprite and the enemy sprite are combined sprites. You squish 2 sprites together and you get 16 color sprites. Color 23 is that cyan color that I had for the attacks that you're shooting and the jump graphic as well. And then finally, 24 to 31 is for the enemy sprite, and that's how I have the colors divvied up. Let's see. I'm storing colors as 8-bit RGB. So 8 bits for each color instead of Amiga has 4-bit color palettes. I'm doing 8 bits internally. And for good reasons, not for higher color fidelity. That obviously doesn't make sense because they have to be squished down to 4-bit anyway, once they're in the copper list. But it turns out if you want to do color effects, so you do additive color blending, other like, you want to make the character flash red or something like that and have like a smooth transition. Even other interesting stuff like desaturating the colors, like like when I did damage to the opponent and the background turned black and white while the bullets were exploding. That's a lot easier to do if you have 8-bit or byte-aligned values, because you don't have to do bit shifting for like the green is like, or what is it? The red is kind of in the lower bits and the green is in the higher bits, and having to isolate those with logical operations and doing bit shifting. You can avoid that just by internally using 8-bit color values. And it turns out that in a single blit with the blitter, you can convert 8-bit to 4-bit colors for, so you kind of have the best of both worlds, extremely efficient conversion and efficient color operations. And I have a small breakdown of how I do this. I have a blog post that goes into a little more detail, but basically you split it up into 2 blitter registers. So one is red and blue and the other is green. Then you use the A masking register of the blitter to get rid of the low bits, and then you use C, put a static data 00F0 in C and intersect that with the green to get rid of the low bits on green, and then you union the 2 together, and that's what you get. Again, for the full code, I have a blog post about this that goes in a little bit more detail. So if you're not versed on blitter operations, then don't worry too much about it right now. Just trust me that it's easy. Oh, and this whole thing for each color, it's only 8 cycles because the blitter is that amazing. A single blit operation for all 32 colors, 8 cycles each, and that's it, just once per frame. I also have a routine for fast HSV to RGB conversion. So I can even set up colors as hue, saturation, and value, and then run them through a function that converts them to RGB very quickly. I found, man, I don't remember if I have the link anymore, but I found this really efficient C function for HSV to RGB, and I converted it to assembly. And this, from the demo earlier, this is where I used it just as part of the demo, where you have this rainbow effect where it kind of cycles through the colors. That was just an example of how I used it in the demo, but that was HSV to RGB. And I think there's a lot more interesting stuff you can do with that than just cycle through the rainbow colors, but that's how I showed it off in the demo. Okay, so we can go a little bit over music next. We talked about some technical stuff, so I just wanted this breather a little bit to talk about the music design process. So this is non-technical, and I'm not the most amazing musician in the Amiga community. I mean, the freaking demo scene is just like the songs that they produce are just absolutely unbelievable. DJ Hoffman, of course, and all of the others who are slightly less publicly visible than DJ Hoffman, so I don't know their names, but they're doing incredible stuff. But yeah, I kind of had to learn the skill as well. I have some, I've dabbled in like music production, so I'm just going to show you a little bit my process of how I kind of come up with this and then convert it into an Amiga track. Let me see, and I'm going to play some audio, so let me mute myself while I do that. This is, so I kind of start out with, I come up with sort of a melody in my head that I just put on piano first, just to get it down, that's like my initial sketch. And so that's what I'm going to play first here. Okay, so that was my initial concept that I just got down on piano. It sounds kind of, it's a little bit classical, sounds kind of fancy, like you can maybe hear this being played on a harpsichord, for example. But but I need to turn this into a boss song, you know, with intense action. And so I need to change up the angle a little bit, make it a little bit scarier sounding, you know. Again, this is for the library level I was talking about. So you're kind of in this library, and the boss character is someone who uses a magical pen to kind of steal your soul and convert it into a biography. And so she's kind of a scary character in that sense. It's like this scary, oppressive vibe. So the next step was to create something more comprehensive in my music software. I just use FL Studio. And when I compose this, I'm thinking about the limited sound channels on Amiga as well. However, I don't try to go one-to-one, like, okay, I only get this many sound channels. I actually try to stretch it a little bit. I don't really mind using chords. I don't mind packing on a few extra samples, because what you can do is you can, if there's like one part of the song, maybe just like half a second where there's like many sounds playing at once, you can render that all as a single sample and play it only on one audio channel. So I deliberately kind of only loosely follow the restrictions of the Paula sound chip when I compose it in FL Studio. So this is a so I'll play, this is a 1 minute clip. I'll just play it out, and then we'll switch over to ProTracker, and you get to hear the ProTracker version of it. All right, and you'll notice that I'm adding a lot of electronic samples as well. There's kind of a drum and bass beat. There's this scratchy, like deep bass, electronic bass, and there's some envelope sweep effects as well. I think that first of all, electronic samples are just very cool sounding, but they also work really great on Amiga because the waveforms are so simple that you can render the sample as just a few bytes of data. And that's all you need to create a really nice sounding electronic synth. But the other thing is, I think like going with this kind of similar theme through the soundtrack helps to set apart the atmosphere of this game a little bit compared to I don't know, the games of yesteryear, where you don't have this sort of soundscape, and that's kind of important to me as well, where there's a lot of people making retro style games where they use the exact instruments of the retro system, or they try to emulate a style that you would hear on the retro system, which I totally respect, and I love that as well, as someone who of course loves these retro systems and the games on them. But I think it's an equally viable approach to try to give yourself a unique identity in this space. And I think it goes along really well with this theme of, again, I'm making an Amiga game, but I'm trying to make it look and feel like a modern indie game. So I think in that sense, it works quite well. Okay, and finally the ProTracker version. And you'll notice that I'm only using 3 audio channels because the 4th one had to be reserved for sound effects. So I'm even more restricted in that sense. But I'll go ahead and play this, and maybe you'll be surprised by how similar it sounds. There we go.
All the voices were there.
Yeah. There were a couple of tiny sacrifices, but not ones that you would really notice unless you like scrutinize them side by side.
How many times do you have to compress the multiple samples of the? So when you got too many voices?
Let me think. It's a handful. It's like I don't go crazy with it. You can't go crazy with it because then you need more samples and then you run out of chip RAM anyway. But yeah, I mean, I try to be smart about it on both sides. Again, I don't do total free reign in FL Studio before porting it over. I keep the limitations in mind, but I try to be a little bit loose about it if there's a specific sound that I want.
Just go.
Exactly. Yeah. Oh, and I forgot to mention my video capture was not cooperating for some reason, and that's why it looks like a degraded VHS tape with the wig.
Yeah. Part of the retro, right?
Yeah, exactly. It works perfectly for the aesthetic.
The fans are static to come across the screen.
Yeah.
There's a plug.
True. So yeah, that was a little touch on the music process. Oh yeah, and if you wanted to hear this full song, I posted it on Mastodon a while ago, so you can look me up on Mastodon and find it. We're going to talk about the Bobs. So, okay.
Yes.
Thank you. Okay. Okay. So this was the problem we had. We have about 200 bullets, or like a max of 200 bullets. We have to update every single one of them, every single frame, at a full 50/60 frames per second. Number two, when a bullet leaves the play area, we have to despawn it, of course. And then number three, we need to be able to spawn new bullets at arbitrary times. So they're spawning and despawning in any order at arbitrary times. And then of course, we still have to run the physics on all of them every single frame. So this was one of the earlier problems that I had to tackle, of course, because it's the core of this game, the magic core, if you will. I'll talk a little bit about how I do the spawning and despawning. Here is some pseudo assembly code. I simplified it a little bit so that it's a little more readable. Like there's no array indexing in assembly, but I just threw that in there. This is effectively the data structures that I have. So let me see if my laser pointer works. I think it basically works. Yeah. So up at the top, I just have a pointer to someplace in this stack. So, well, actually, I'll start at the bottom. First of all, we have an array of 200 bullets, obviously. The bullets, it doesn't matter how big each bullet is. We can say it's like 16 bytes or whatever. We have an array of 200 of them. Now I have a stack called the free bullet stack. This stack contains 200 pointers, one for every single bullet in the array. And when I first initialize it, it's just in order. So again, the first pointer is bullet 0, the next one's bullet 1, the next one's bullet 2, etc. Because all the bullets are free. We haven't spawned any yet. And now finally at the top, I have a pointer to the current entry in the stack we need to concern ourselves with. Again, no bullets have spawned in, so just the first bullet in the free stack is the one we're concerned with. So let's spawn a bullet. This is all we have to do. We look at the next bullet that's free, which it tells us right here is bullet number 0. And then we spawn the bullet in the array in position of bullet number 0. And then in this stack, we just move it down. And I'm zeroing out that top entry of the stack just to make it visually a little bit more clear. You don't actually have to do that. Yeah, so now bullet 0 is no longer free. We spawn an object there, so it's no longer in the stack of free bullets, obviously. And we update this pointer up here to point to the next entry in the stack. So let's spawn another bullet. It's the same thing. You just grab the current the current free bullet, spawn an object to it, and then move down to the next item in the stack. We'll spawn another one. But now let's say the very first bullet we spawned, bullet number 0, let's say it leaves the screen and we need to despawn it. All we have to do is the reverse. We move up the stack, put bullet number 0 back onto the stack as the current free bullet, and then decrement this number. So we're kind of just moving up the stack like that. And the order really doesn't matter. Like that can be bullet 0 and then maybe The next bullet leaves the screen is like bullet number 2 and then bullet number 1. And now next time you need to spawn a bullet, again, this is just the list of free bullets, so we can move that way and we spawn these bullets and then we free them in any arbitrary order. And this is how I created a simple data structure to solve this problem of like not having to traverse the array and like find a free entry in the array every time I wanted to spawn a bullet. This makes it just extremely fast and simple to arbitrarily spawn and despawn them in any order. Maybe for people who are coding in C with data structures all the time, this is an obvious solution, but again, I had this challenge very early on in development before I was too used to working with these data structures, and so I was pretty happy with this solution when I came up with it. And speaking of despawning, there's bounds checking. We got to figure out when a bullet leaves the screen. And that is pretty easy. Here's a C function that does it. All you have to do, so you have an upper bound, say it's, 320 because that's the horizontal width of the screen. So all you have to do is, if you want to check if it's in bounds, is the position greater than 0 or greater than or equal to 0? And is it less than the upper bound or 320 or whatever it is? That's great, but we can do this in one comparison instead of 2. We don't have to check both 0 and upper bound. We only have to check upper bound if it's an unsigned integer, because if the position goes less than 0, if it's -1, well, as an unsigned integer, that's something like 4 billion. It wraps around. So if we treat it as an unsigned integer, which is just, you use the correct branch instruction in assembly instead of it caring about the condition flag for whether or not it's signed effectively. You just swap out the instruction for unsigned comparison. And then you get to do it in one comparison instead of 2. And again, over the course of 200 bullets, when you want to optimize this loop, it makes an incredible difference. Just simple optimizations like this. And that carries into the physics as well. So now we're actually going to get a bit of a chunkier piece of assembly code, but don't worry, we will walk through it. This is a very basic physics routine. First, you grab the X position, put it into register 0, grab the Y position, put it into register 1. And then you add the X velocity to register 0, you add the X velocity to register 1. And then presumably later down, you take those registers and you write them back to the data structure. And then there's the bounds checking as well. You have the new X position and the new Y position in these registers, and you're just comparing them with the bounds and destroying them if they are out of bounds. But there's a pretty interesting optimization we can do in this physics routine, which is a little bit of a cheat, and it's not perfect, but it is perfect enough for my use case. And this is what it is. We use 32-bit addressing instead of 16, or 32-bit instructions, I should say. So the X and Y position are 16-bit values that are right next to each other in memory. So we can use a single instruction to just move a 32-bit long word into a single register. And then we can do the same for velocity, where we add 32 bits, X and Y velocity to this register that has X and Y positions. And that actually saves a good number of cycles to do that. And we can go ahead and break it down here. I just provided this little look at the registers, so it's a little bit easier to understand what's going on. So the first instruction, we just grab the X and Y position, we put them into register 0. So the upper 16 bits are going to be the X position, and the lower 16 bits are going to be the Y position. Then we grab the velocity, X and Y velocity, again, 32 bits in a single instruction, and we add it to the 32-bit position. Upper 16 bits get added for X, lower 16 for Y. The side effect here is that if Y is negative, then you're going to have, FF something something, but you're doing addition, and then there's going to be a carry. So the upper bit of Y, if it's negative, gets carried into the lowest bit of X if you perform this optimization, because you're adding a 32-bit number, not two separate 16-bit numbers. But if you have fractional pixels that are small enough, subpixels, then this is not really consequential. And this is a simplified view in my actual game. I have small fractional pixels for each of the bullets. And so if there's that tiny inaccuracy and getting carried over into the X position, then it's actually not that big of a deal. Okay, and then finally, we have X in the upper and Y in the lower 16 bits. So for the balance checking, when we're checking the X bounds, we actually had to put the upper bound in the upper 16 bits and then compare longward between these two. And then for Y position, it's just in the lower bits, so we could do the normal lower 16 bits comparison. And all of these optimizations added up between the bounce checking and the physics routine, I think saves about 20 cycles, which multiplied by 200 is what, 4,000 cycles every frame. That is very, very substantial for what we're doing. So yeah, not trying to over optimize at this point. I already made that mistake. And then it turns out if you want to make one tiny change to the way your engine works, you have to like rip everything apart. But these optimizations are pretty fundamental and I think a large part of how this game works in the first place. Okay, one more thing I want to talk about regarding the game design is what I call spirographs. So you probably noticed during the demo, I mean, there were some cool attacks, like there's the sphere attack at the end, and there was
The Adobe Acrobat.
thank you. That's what I call it too, the Adobe Acrobat. Yeah, so I wanted to talk a little bit about how I'm drawing those. And again, like how it's being done quickly, you know, that's kind of like, it looks kind of like a demo scene effect. It's really exciting to be able to put that in actual gameplay, you know what I mean? And I have an amazing system for creating those effects. And I'm going to explain it using these video clips I took from another game on Steam called I Want a Maker, where you have a spinning stick and you have a bullet at the end. In this case, it's that piece of fruit, whether it's an apple or a cherry, no one will never know. But so you have this spinning stick, and basically all you do is, let me get out of this. Okay, let me play this video. This is pretty much all it's doing. And of course it's drawing all of those in a single frame. You know, it's stepping 10 times around and drawing every single one of these bullets in a single frame. But that's pretty much it. It's a sine and cosine of a certain angle. And then depending on the length of the stick, I am multiplying the sine and cosine by a certain value. So I am using multiplies here. I don't think there's really any way around it in this case. If you want arbitrary lengths of this stick here. But that's pretty much how I'm doing it. But this only makes circles, of course, because it's just sine and cosine all the way around. So how do you make more complex shapes? You stick two sticks onto each other. So you do a sine and cosine of one angle, and then you add, and then you do a sine and cosine of another angle, and you add that on top of it, and you could do different stick lengths for each of them. And now watch when I play this. Look at the interesting patterns that it's making now, just by sticking two of these on top of each other. So it's all just sine and cosine. And now if I show you the spawner, this is what it looks like.
Orbital mechanics.
It's Adobe Acrobat. So yeah, and just by playing with the length of each stick and the speed at which each of them are spinning relative to each other, positive or negative, and simple values like that, you can make just all kinds of crazy and interesting effects. Like here's another simple one where the second stick this time is shorter and spins a little bit faster. It creates sort of like this 4-petal flower kind of thing going on. And I was messing around with this a lot. I even have a little tool in my game engine to mess with the properties to see what interesting shapes I can make. So I found a couple just video recordings from early in development of me messing around with this. Here's like a weird thing that I did. And the bullets are not actually moving back and forth. Every single frame, I'm drawing a new set of bullets, then I'm wiping it, slightly changing the parameters like the speed of the sticks, and then drawing a new set of bullets. And it's just because I'm slightly tweaking the parameters each frame that it looks like it's animated, but it's actually drawing a brand new set every single frame. The bullets aren't actually moving. And then let me see. And here's another interesting one when I was messing around with like how to make kind of 3D looking stuff. Before I had the sphere totally worked out, I was using this spirograph technique to create kind of these ellipses that kind of change their, they sort of stretch and squish. And I saw that and I was like, this could work really well for like a pseudo 3D effect. And that's how I did the sphere. It's entirely just sine and cosine. It's just ellipses stacked using sine and cosine to create the different angles. So this ended up becoming a very key part of the game engine, and I plan on using a lot more of those effects in the future. Okay, so how are we on time?
Perfect.
We're still doing okay? Let me double check here to see how much I have
We got about
left.
15 minutes.
Okay,
So
okay.
for what?
We're sort of
15 minutes for what? For dinner.
Oh yeah, well, it's fine. We're getting to the end of it anyway. I think we're done with most of the technical stuff, so we can take a little bit of a breather there. I mentioned hardware collisions. It turns out that Amiga has just incredible hardware collision support. You can, check collisions between different sprites, or I think different groups of sprites technically, between sprites and bit planes, which is how I'm doing it in the demo. I just have the character sprite, and literally for free, it tells me if the sprite has collided with the bit plane that the attacks are on. And that's pretty much it. I'm done with collisions. It's absolutely free. And that's actually really amazing. It's pixel perfect collision. But it doesn't really end there because there's no lenience, right? So for example, my character has hair that's kind of whipping around as she's jumping and attacking and stuff. And it feels kind of unfair maybe if like the back pixel of her hair, because you're running and it's flying behind her, like touches a bullet and then you take a hit because of that. Lenience feels really, really good in video games. You want to create those close calls for the player. Think about even like Pac-Man, for example. It's like you like round the corner and the ghost kind of touches you and you're like, and you just get past it, and just like, it feels really awesome when you have those moments and you really remember those. So we want to create those and introduce some kind of lenience into the collision system. But how are we going to do that with Amiga's hardware collision that just checks if a pixel is overlapping another pixel? As I mentioned, the hair should have no collision, so we can start to think about this. There's one solution where you just have the hair on a separate sprite. And then maybe depending on the way the sprites are grouped together, you can, only check collision for the sprite that doesn't have the hair. But I think this is an imperfect solution for a couple reasons. One, it makes the colors a little bit complicated maybe, because now you have an attached sprite for the character and you have to make sure the sprite with the hair is like aligned with the correct color palette, which I already have divided in like a very specific way. But aside from that, I want more lenience than this. The character has a black outline around the whole sprite, which is by design, and it's kind of the same thing where I don't really want that to widen the whole character's hitbox just to have that outline there. So I came up with another interesting solution, which is to use the blitter. The blitter has a flag called, I think it's BLT0, which is every time you perform a blit, if it actually blits pixels onto the screen, any pixels at all as part of your blit, then it clears the BLT0 flag. If you perform a blit and it doesn't write any pixels, then it sets that flag. So the question is, when would you actually perform a blit where it's not actually blitting any pixels to the screen or you're not copying any data? Well, this is your example. So what I have is, or what I'm going to have anyway, this is a planned system that's only half implemented right now. I have a version of the character sprite that is just a one bit per pixel sort of version of the sprite that kind of looks like, I don't know, like a weird Atari 2600 character or something. So it doesn't include the hair, it doesn't include some of the dress, and it doesn't include that black outline around it. So it's really more honestly like what your character actually is. So I have this in memory as just like a 1 bit per pixel version of the character. So then every frame I can look at where the character is on screen, do an intersection blit between that part of the screen. Let's say there's a bullet there, like right here. I take this 1 bit per pixel character, intersect it with that part of the screen, and check the output. So in this example, the output is just this little cluster of pixels here. And I don't even have to write these to a destination. We're not often using the blitter where you're not actually, where you turn off the destination register, but this is an example where you would do that. Because again, if no pixels exist in the intersection, it sets this bit. And if we do get pixels, then it clears the bit. So there's your collision detection. It's not literally free, but this is a tiny little blit. The character is maybe like 12 pixels tall. So that only takes a few cycles to perform collision detection on a screen, again, that is just blanketed full of maybe 200 bullets. So that's my solution for lenient collision detection in a game like this. Okay, and now I'll just talk a little bit about the release plans. We're reaching the end here, and I can get a drink of water. Okay. This is going to be an NTSC release. This is not a PAL, this is an NTSC game, and I'm in. This is the one crowd where I can say this. This is this is America. Thank you, I appreciate it. Yeah, I appreciate it. So, no, but I have some good reasons, and I'm going to go through them, and then maybe you'll put your pitchforks down. The first thing is, again, 99.9% of the audience is going to be on Steam, or playing it on an emulator, maybe. That's just where my audience is. That's where everyone's going to play the game. So it's not only smoother frame rate because you get 60 hertz instead of 50, but especially for video recording and streaming, which is obviously really big and important for gaming nowadays. Everyone is streaming and recording at 60 frames per second. So I don't want to have to deal with like this game full of intense, fast-paced action to be dropping frames in the live streams because it's running at 50 hertz and then the stream is at 60. And same with YouTube videos, of course. So that's actually like a really important consideration, I think, in releasing this game in order to give everyone the best possible viewing and in some cases playing experience. Here's another thing, 320 by 200 is 16 by 10, which is a very well-supported resolution, very close to 16 by 9. And I mean, you might be thinking, well, it's 4 by 3, right? It's not actually square pixels because you take that and you stretch it to a 4 by 3. Well, guess what? We're also using square pixels in this release. So I'm committing 2 sins. We're doing NTSC and we're doing square pixels. So if you want to play this on real hardware, then you have the benefit of CRTs with adjustable displays. You can actually squish the screen and stretch it to the correct aspect ratio. But again, if you're playing an emulator, you're playing on Steam, the expectation nowadays with indie games is to have crisp and clear square pixels. So there is no way that I'm going to, use some kind of blurry filtering to stretch the pixels on these platforms. So this just seems like the obvious way to do it. You have a nice aspect ratio, you have crisp square pixels for people playing on Steam. And then again, on the old hardware, you can stretch the screen accordingly. If I just put, in the menus, like a graphic, like a circle or something that you can use to get the aspect ratio correct, I think that'll definitely be good enough. And also PAL will still work, I think, if I'm going to be honest, I think you're going to need a bit of a slower gameplay experience if you want any luck with this game, looking at this audience. So playing it at 50 hertz instead of 60 might actually work in your favor if you want to play it. Yeah. I mean, or maybe I'm misjudging you. Maybe when I set up the game later over there and you give it a shot, you'll actually crush it and impress me. But somehow I doubt it.
Words.
All right. So, okay.
You just need his hat up. In there.
All right. And it's probably going to release sometime in 2025. the game engine is looking pretty good at this point. I mentioned I have to develop all the final game assets, all of the levels, all of the narrative, the music, and the artwork. There's still a lot left to do on the game design side, so I'm thinking 2025 is going to be a reasonable target for this release. Okay, quick sneak peek of the characters, because why not? This is our main character. We're going for very simple color palette. This whole thing is like maybe 5 colors at most. You have the blue, you have the skin tone, the white of the socks, the off-white of her hair, and then the black outline. I think that's pretty much it. And it's not only very stylistic, artistically, to have this simple color palette and kind of these dark, sort of cell shaded shadows. It's kind of very edgy looking with the simple shapes. But of course, it translates really well to having these little sprites, the character sprites on Amiga, where you only have a few colors to work with. During the gameplay anyway, the characters maybe get 6 or 7 colors. The portraits in the dialogue is, and I didn't really talk about that, but the dialogue box is just its own completely separate 5-bit planes, and so I get a full color palette for the characters in the dialogue box, but this translates really well to the actual gameplay. This is Watanabe, that's the character from the demo. So we kind of finished her design. She really loves rumors and gossip, and is kind of evil, just likes causing drama by spreading them. But she talks about them like being delicious and tasty and like, and that sort of thing. So we wanted to lean into that a little bit. So we gave her this sort of floating custard hat, and wanted to design her dress to sort of look like a box of sweet, like a wrapped box of sweets. We want to give like an interesting standout detail to each of these characters to make them a little bit more memorable. So in this case, it is, you know, the custard hat is pretty hard to forget. This is Liliana. It's the librarian that I was talking about. She's kind of like an overworked shut-in who doesn't want to deal with people. So she has like a little bit of the professionalism going on with, you know, she has the tie and she has sort of the slit in the bottom of her dress. But we wanted to give her the witch hat because it's kind of droopy and makes her look a little bit more tired, you know? So it's sort of this interesting intersection between professionalism, but just like being overworked and unkempt, I think is the word I'm looking for. And then we have this interesting loop in her hair that's kind of like an inkwell. So it's just a loop, like a big ring, but then when she uses her power, it would fill up with ink, and then she would, you know, dip her pen in it and use her pen. So that's kind of her standout feature, is the inkwell in her hair. And this is her assistant, Shizu, who is new to the job. So she's kind of the exact opposite, extremely gung-ho and energetic and excited to help out. And for some reason is Liliana's #1 fangirl, despite them having opposite personalities. So we have this very cute dynamic going on that's going to create a fantastic narrative experience as you work your way through this level. You know, you meet Shizu, who's talking about how great Liliana is and how she can't wait for you to meet her. And then you meet Liliana and she's like tired and angry and tells you to go away. I think it'll be a very fun narrative to play through. And that's it. So thanks for sticking all the way through. Again, if you want to learn more, you can, you know, I have some posts on my blog. You can find me on social media. I'll try to keep posting updates about this game. It was really great being here, being able to share all of this. I never get to talk about this stuff, so it was great getting it all out. And
Great job.
Thank you.
Fantastic.
Thank you.
When you put the game on Steam, it's gonna be just run on an emulator in Steam.
It'll be wrapped in an emulator, and I think the licensing allows for that, for me to package the emulator in like a commercial package. I haven't looked into it yet, but I think I've seen other games do it, so I'm not too worried about it. And I've seen other Steam games do that for like NES games and stuff like that. It's just wrapped in an emulator.
You pretty good with litter bin terms?
I've started to get there, but no, I think the VS Code extension at this point, I don't know if let me take a look real quick.
Actually, if you bring up a browser,
Uh-huh.
got a cheat for you.
I use the Venn diagram.
Oh, I got another one.
Do you?
Yeah.
I don't want to bring up my web browser on stream because I don't know what my recent tabs look like. You know. As a guy who seems to be really into anime, I got to be a little careful.
It's for research, it's for research.
Yeah.
Go to wiki.amigaos.net
Yeah.
and type in min terms.
Okay.
And there's an entire article on how they really work.
Oh, awesome. So with like the getting in depth about like the logical.
Yes.
Okay.
Because it's hard.
Yeah. No, I use there's this great Venn diagram that was in the Amiga hardware reference manual where each circle represents A, B, and C.
Yes.
And then there's just numbers in the diagram for, which are the bit numbers. And I've been getting by with that just fine.
If you like that art.
And I think.
Wanted to pull up this browser.
Yeah.
I just happen to know the author. That's
Okay. Well, yeah, not pulling up the browser, but I think maybe I don't have the latest version of the extension, but I think they added a min-term helper in the VS Code Amiga assembly extension. Oh, you're the author of it. Okay. That's why you're plugging it. Okay. Once I stop the screen share, I will.
He's just trying to tell you how awesome he is.
Yeah. I believe it.
He knows he's old.
He's just old people know something.
He's just completely intimidated.
No, I believe it.
Don't buy it. He's just intimidated and jealous.
I mean, you guys are out here writing freaking operating system kernels. I'm just making this shitty little video game. So.
It sounds it's just as complicated from all the different fields you touched.
Yeah. Yeah. No, but I mean, I'm gaining a huge appreciation for what everyone is doing here as well. It's very outside of my wheelhouse, but it's just as amazing for me to see.